South Africa, a country where necessities are a challenge and reality in poor communities. OKAF SA is on a drive to make a positive change in people's lives. Our work is deeply rooted in the ethos, history and belief of our religion. Through your Waqf donations, we are building a brighter future for education, healthcare and infrastructure, and fulfill a sunnah in paving a way towards a brighter tomorrow. With your support, OKAF SA has the power to transform lives for generations to come. Donate today and build a foundation for a brighter tomorrow. OKAF SA, creating an eternal legacy of hope and dignity.
Oh man, that's how we started. How's a round of applause? Welcome to the OKAF SA Grade 12 Maths Workshop, coming to you live in effect here from Spine Road High School. Subscribers and viewers online, hit us up via YouTube. Let us know from which school you are connecting to us from, as well as from which province you are connecting to us from. We are going to be calling on one of our key partners for this program. We're going to be calling on Mr. Ronald Engelbrecht from the Western Cape Education Department. A round of applause.
Good morning, grade 12 learners. Good morning, teachers. Good morning, Mr. Kota, who will be the facilitator of this maths workshop, and also to the Awqaf representatives and colleagues, our teachers who are here today. Welcome. It is a pleasure to welcome you to our SIND workshop. Last year we were in August, correct? In August, that's why I think today is a little bit cold. So students, I just want to say to you, today is not just another day or another school day or going to be another weekend. Today is an opportunity. It is an opportunity to reflect, to focus, and to ask questions, to correct your mistakes, and to take another step towards success in mathematics. To our grade 12 learners, thank you for being here today. Your presence already says something very important. It says that you have not given up. It says that you are willing to reset and retry. It says that you still believe that improvement is possible. And I want to say to you very clearly this morning, you are right to believe that improvement is possible. We have looked at your results at the term 1 mathematics grade 12 results across Metro South. The results tell us a few important things. They show that there are some learners who are performing excellently. Across the district, there are already learners achieving distinctions. That means excellence is possible in our schools. But the results also show us that many learners are not yet where they want to be. Is that correct? Is that correct? But some are just below the pass mark. You know, and you know what's the pass mark? A meager 30%, right? Some are passing, but only just. Some are close to 50%, which is, of course, the bachelor's mark. Is that correct? That's the bachelor's mark. But again, that in itself isn't enough. It is about the 60%. That's really important. And we want as many learners to obtain 60%. And so some of you might feel that maths has become a bit of a challenge or very difficult. And the gap to recover is too big. But let me remind you, term 1 is not the final exam. Is that correct? Term 1 is not the final exam. Term 1 is a warning light, not a final judgment. A warning light is not there to embarrass you. It is there to tell you where attention is needed. It helps us to see what must be fixed before it is too late. That is why this workshop, this weekend, is so important to each and every one of you. Mathematics is not passed by luck. Mathematics is not passed by luck. It is improved through practice, through correction, and confidence that you build as a result of repeating that process. You improve when you try a problem. You improve when you make a mistake and actually work at it and understand the mistake. And then try again. That is how mathematics grows on you and grows in you. So today, I want to encourage you to do 3 very simple things. First, be honest about what you do not understand. Do not hide behind the gaps. Do not conceal the gap, because a concealed gap or a hidden gap cannot be fixed. A question that is never asked cannot be answered. Secondly, participate fully. Be engaged. Okay? And we have a personality in Mr. Kota that will make sure that you do that. So work with him today. Attempt the examples that you are given. Ask when you are stuck. Your teachers are here. So please do ask. And even put up your hand as well. Write things down and use this time well. Thirdly, believe that small improvements matter. Moving from 25% to 35%, it matters. Moving from 38% to 45%, it matters. Moving from 48% to 55%, it matters. Every mark you gain gives you more options, more confidence, and a better chance in the final examination. So to the learners who are struggling, this workshop is for you. You are not here because you have failed. You are here because we believe you can still improve. To the learners who are already passing, this workshop is also for you. Your task is not only to pass, but to strengthen your mark and aim higher. To the learners who are doing well, this workshop is for you too. Excellence must be protected. A strong term 1 mark must become even stronger in your final result. We are grateful to Awqaf for investing in you and our learners. Your support is not just support for mathematics, it is support for your futures, families, schools, and communities. Thank you for seeing the potential in young people, Awqaf, and for helping us create this opportunity. We also thank Spine Road hosting us. Your school is part of the Metro South mathematics story, and it is fitting that learners gather here today to learn, to grow, and to prepare. Learners, the final examination may still feel far away. Decide your final result starts namhlanje, starts now, starts today. Every workshop, every lesson, every homework task, every past paper, every correction, it counts. So make today count as well. Do not leave this workshop the same way you came in or the same way you arrived. Leave with at least one topic clearly mastered. And I noticed that Mr. Kota asked some of the students, where's the difficulty? What are you challenged with? So leave, ensured that you have mastered that particular topic. Grade 12 is not easy, right? Mathematics is not easy, but you are not alone. Your teachers, your schools, the district, and Awqaf, and for everyone here today, are standing with you. So let us begin this workshop with focus, respect, commitment, and hope. I wish you a productive weekend and a successful weekend. Thank you so much.
We say thank you to Mr. Ronald Engelbrecht. Very briefly, we're going to have a very brief greeting from the school. Ms. Fortune will just briefly do the welcome from Spine Road High School.
Good morning, South Africa. To Milani, Assalamu alaikum wa rahmatullahi wa barakatuh. Spine Road High, as one of the partners of this initiative, would like to welcome all of you here. The welcome comes on behalf of the school, the management, and Mr. Fairbairn. I have just a very small message. I don't know if you noticed that small jigsaw piece that was on the screen. So today's and tomorrow's session is that piece that will complete your jigsaw puzzle. Okay? You must also consider this session as a baton. Mr. Kota, the young, enigmatic young man sitting here, he's going to give you the baton. Now you need to run to the winning post as a winner. Okay? Overcome all your your difficulties and you know the nightmares when it comes to trigonometry and geometry. Tomorrow you're going to be a winner. So welcome and have a wonderful session. I wish you all very, very well. Thank you. Bye.
Okay. So we're about to get the show on the road. We're calling on Mr. Kota. He'll be the facilitator for the session. Please use Mr. Kota as a resource. He is full of energy. He knows what sort of a questions that's coming in the paper. So listen to him. Mr. Kota, it's over to you. Take it away, my man.
Morning. Are we live? Good morning, South Africa. Good morning, Cape Town. On this beautiful day, got here to Cape Town yesterday and thought that I will be taking the next flight out of Cape Town when I saw the weather. But yeah, beautiful morning. I think you guys all from all your different schools that made it early this morning. Give yourselves a nice round of applause. Right, we got learners coming in from the back. Just settle at the back. Let's get started. Take a deep breath. Let's get up our whiteboard. Let's get up our whiteboard and let's get started. Guys, what do you need for today? You need your scientific calculators. You need your stationery, your exam pad. We're going to start off with some algebra. And then we are going to be doing inverse functions and functions. And then we go into our big topic of calculus for today. And then we will end off with some sequences and series. So today being paper 1, tomorrow paper 2. There's a whiteboard up. Take a deep breath. Let's get the show on the road. Okay, guys. Now, the first thing that we need to know, which I know you all know this. But settle down. Factorize to 12 for x. Now, the reason why I need to show you this is because we need this for tomorrow, for paper 2. General solution, trigonometry, 8 sine squared x minus 2 sin x minus 15. Now, if you were part of our workshops before, you would know the method that I use. Yeah, we use method. Right. Now, you all know what. Right. Now, please go and write snot cop in your exam. Your teacher will write there WTF. Right. Now, you know what a snot cop is. There's his eyes. There's his nose. There's his mouth. So you see eyes, nose, mouth. And then you're going to have 2 tears. And then you're going to have the snot dripping in the mouth. Right. So what are the eyes, nose, mouth? Let's go. The eyes, 8 and 15. Please learn this. We're going to be utilizing this a lot. 8 and 15. So welcome to all our onliners from all the different schools. Hit us up in a comment on YouTube, Facebook, Instagram, TikTok, where you guys are joining us from. Let us know where you are coming in for. So 8 and 15, 8, the first and the last are the eyes. Yes or no? Grade 12, are we all okay so far? Good. 8 and 15 are the eyes. We got the nose in the middle. That's what goes in the mouth, minus 2. Now, we got the eyes, nose, mouth. What am I short of? Tears and the snot. What are the tears? Factors of 8, 4 and 2. Yes or no? What are your factors of 15? 5 and 3 or 3 and 5, right? Guys, do I get a thumb up so far? Is everybody locked in? Are we good so far? Good. So let's go. 4 times 3 is 12. 2 times 5 is 10. Can a 12 and a 10 give me a minus 2 when adds? It can. This has to be minus 12, that must be plus 10. Yes or no? Negative times positive is a negative. And what's my last sign? A negative. So we don't think we right, we know we right. 4, 5, 2, 3. So if many of you don't know how to factorize, please use Mr. Snotkop on the side. So let's go. 4, 5, first bracket. There we go. 2, 3, second bracket. And then we got x squared. So we're going to put x times x. Now, which bracket gets the positive? Which bracket gets the negative? Let's start here in the middle. 5 times 2 is 10. What do I need? Plus 10. 3 times 4 is 12. What do I need? And there we go, fully factorized. There we go, fully factorized. So now we know 4x plus 5 equals to 0. 2x minus 3 equals to 0. Let's solve for x in each factor. X is equal to, in grade 12, divide by 4. We got minus 5 over 4. Or 2x is equal to 3. X is equal to 3 over 2. So there we go, you Mr. Snotkop. Remember, today is not about getting the answers. Today and tomorrow is about getting the systems right to get to the answer. Are we all okay with this? This is easy stuff. But I thought I'll let you know, because we're going to be using this tomorrow heavily, even in your double and compound angles tomorrow, and general solution. Yeah. I had something very interesting that I came across this week. If you thought you knew a hyperbola with a shift in asymptotes, if my memory serves me correctly, I'm going to show you a killer one. One that you never saw in your life. And I know, when they say hyperbola with a shift in asymptotes, you all say, come on, chips, piece of cake. I'll show you one today that will make your poop so small. You'll be clapping in the exam. It's coming. It's coming. Right, let me give you one. Right, so here we go. I've given you that one. Let's see if you guys can do one on your own using the Snotkop method. Let's go. I tell you, 6x squared minus x minus 15 equal to 0. Go for it. Go for it. Use Mr. Snotkop. Eyes, nose, mouth, tears, snot. Shh. A problem like this shouldn't take you more than 20 seconds. So you got 20 seconds and your 20 seconds start now. How's our comments coming in there, Khalid? Our onliners on fire there. Are they cooking? Sorry? No idea. Welcome, onliners. So your factors of 15, that when cross-multiplied will give you -1. Did you all do that? Good. 2 factors of 6, 2 factors of 15. Cross-multiplied to give me -1. Easy stuff. This is baby work. Bruh, if you can't do this, go and do diet maths. Maths 0. Maths light. 0 sugar. Right. 3 and 2. 5 and 3. Did you all get that? Good. 3 times 3 is 9. 2 times 5 is 10. Can a 9 and a 10 give me a -1? That must be negative. This must be. And a positive times a negative is a. Do we think we're right or we know we're right? Right. So let's go. Factorize equal to 0. What's your first bracket? 3, 5. What's your second bracket? 2, 3. What do I need here? X squared. So I'm going to put x and x. Where do I start? I start with the 2 next to each other. 5 times 2 is 10. What do I need? Negative. 3 times 3 is 9. What do I need? I don't think I need to go forward from here. I think you know what to do. Yes or no? Good. Lovely. You now know how to factorize. Okay. Let's throw you into the deep end. Let's throw you into the deep end. Can I raise? Are we all good? You took it down? And remember, this is recorded, so you can always go back to OKAF SA and you can re-watch this one and re-watch all these problems that we are doing. Okay, here we go. Solve for x. Solve for x. Square root of the square root of 32 plus x into the square root of root 32 minus x equal x. Here we go. Here we go. What do we do? What do we do here? We're going to do these, and then we're going to do one simultaneous equation. Then I'm going to show you how to do inequalities. Very important. You're going to need that for number patterns as well. Show you the systems. Then we go into inverse functions. Right. Now, Now, when you have the square root of a number multiplied by the square root of a different number, that becomes the square root of the two numbers multiplied by each other. So now we're going to have root 32 plus x into root 32 minus x equal x. I'm going to put a tick there. Do you all understand what I did? Right? Remember, if you got square root of a multiplied of a, what's your answer? A. But if we have the square root of a times the square root of b, what's your answer? Square root of ab. Yes or no? So here we go. If this is a and that is b, then this is the square root of ab. Yes or no? Good. Don't forget that. Don't forget that. Now, what do? We square both sides. So square sides, that side. That will cancel out. What am I left with? I'm left with root 32 plus x into root 32 minus x equal x squared. I'm going to put a tick there. Are we all good, guys? Grade 12s, are we good? Beautiful. Now, what is this? This is the difference of two squares. So what do I have? The two first and the two last. Because the inner, remember from FOIL, when you're doing difference of two squares, your outer and inner will kick each other out. So you can just do the first and last. So root 32 times root 32 is 32. Minus x squared is equal to x squared. So let's take everything on the other side. 0 equals x squared plus x squared minus 32. Right? I took this on the other side. I took that also on the other side. So 0 is equal to 2x squared minus 32. Let's solve for x there. 2x squared minus 32 equals 0. Let's divide by 2. Let's divide by 2. We're going to get x squared minus 16 equal to 0. Let's break that up equal to 0. X minus 4, x plus 4, x is equal to plus 4, or x is equal to minus 4. There we go. You can check your validity in your exam. Substitute each one and see which one is valid and which one is not valid. Learn. Learn, grade 12s. Learn. I'm smiling because I'm going to give you a higher order question next. The next one, many of you have seen it, many of you haven't seen it. The next one, you're going to think you've been hit by a bus. How are we doing? How are we doing so far? So far, so good, guys? Beautiful. Nothing like a fresh cup of mathematics on a Saturday morning. Okay, those of you who took this one down, have a look at this one. If 5 minus root 13 all over 2 and 5 plus root 13 all over 2 are two roots of ax squared plus bx plus c equals 0. Find A, B, and C for 4 marks. Okay, this one's not so hectic. The one afterwards. Let's go, grade 12s. That's the question. Now, many of you who attended our NBT prep, we had a workshop in Johannesburg about a month ago at the Kilani Mall movie theater, and we had learners from across the country joining our NBT prep. These are the type of questions you could see in DBE exam as well as NBT. So they're giving you the two roots. Where do you start? Are you waiting for me to do it right? So in your answer, watch here. We know that 5 plus minus root 13 all over 2. So that's your two values of x. Yes or no? And we also know, right, put down your pens. Put down your pens. So these are our two roots. And what do we also know? That x is equal to minus b plus minus the square root of b squared minus 4ac all over 2a. Yes or no? Now I'm going to show you a trick. We call this mapping. What do we call this? Now watch here. Put down your pens, otherwise you're going to miss it. So here we go. There's the 5. There's the minus b. Minus b equals 5. B equals minus 5. 2a equals 2. A equals 2 over 2 is? And now what do we have? B squared minus 4ac is equal to how much? Do I have B? Yes. Minus 4a is 1. C equals 13. 25 minus 4c equals 13. Minus 4c equals 13 minus 25. 13 minus 25 minus 12. C is equal to 3. There's A, there's B, there's C. So your final equation is ABC. X squared minus 5x plus 3. Boom. Done. A, B, C. Taken from here. You like? You like? You don't? Let's double check. 5 plus minus root 13 all over 2. So minus b equals 5. B equals minus 5. That's good. 2a equal to, a is equal to 1. B squared minus 4ac equal to 13. So b squared minus 5. That's 25 minus 4. A is 1. C minus 4c 13. minus 25. Think we right. Beautiful. Khalid, you got a fantastic bird's eye view there from the top. I hope you're taking some crazy pics from the top for our social media. Now the next one is going to silence you. You know, math has got a way of humbling you, right? You want to be humbled. Let's humble you with the next one. This is easy stuff. Then I'm going to show you a crazy way of solving inequalities, which you're going to use not only in inequalities, you're going to use it for nature of roots, you're going to use it for number patterns, you're going to be using it for circle analytics tomorrow, and you're going to be using it for calculus also. So I'm going to show you how to solve inequalities, a quadratic and a cubic. Right, check the next one. I'm sure you all took this one down. Yes, I'm taking off the question. Here we go, here we go. This is the one I want you to do. Consider the product. Consider the product. Consider the product of 1 times 2 times 3 times 4, that's a 3, times ... times 30. Just consider that. You know where I'm going with this. I think many of you know where I'm going with this. Find the largest value of k. Find the largest value of k such that 3 to the power k is a factor of this product. Oh yes, remember we have to do this question is 4 marks. We have to do pre-calculus as well. Have you done the factor and remainder theorem in school? Let me see, show of hands, grade 12. Have you all done the factor and remainder theorem? Who hasn't done it? Okay. You're in trouble. Now, some of you now are just smiling because you know, some of you are just looking and say, if I saw this in the exam, that's the end of me. Maths is, me and maths, we are not mathsing. Come grade 12s, consider the product, find the largest value of k such that 3 to the power k is a factor. All right, be honest here. Come, let's play the honesty game. How many of you don't have a freaking clue how to do it? Now we're friends. That's why we're friends. Right, watch. Shh. So what are your factors? Right, so you got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Find the largest value of k such that 3 to the power k is a factor. So what is 3? 3 times 1, yes or no? What is 6? 3 times? What is 9? What is 12? What is 15? What is 18? Yeah, okay, so it's 3 times 6, but there's a 3 included in there as well. So it's 3 times 2, yes or no? Right, what is 21? What is 24? 3 times? What is 27? Is 30. Right, 3 to the power. Find the value of k. Find the largest value of k such that 3 to the power k is a factor. So how many 3's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. K is equal to 14. WTF, Mr. K! How many 3's are in all the factors in 12, 15, 18, 21, 24, 27, 30? How many 3's are there? Let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. Yo. Sorry. My foes. My bad. You came to get destroyed. This is what you came for. If you came for the same stuff that you saw at school, why the hell waste your time on a damn weekend with me? Right. This is what got Rory Sang 100 in math after attending our project. This is what got the girl last year 98% in math. That's how our students get 100 when they're playing on the A game. How can you your C game to an expected distinction? No, not happening.
And we got Jada here in the front row here. Jada, I think this year she's going to get 100%.
Our top student in grade 11.
Yes. But you know what she's studying?
Yeah.
After grade 12, actuarial science.
Mashallah, congratulations.
This is Jada in front. Jada, just put your hand up there.
Say hi.
Hi, Mom.
She's too shy now. She's too shy. How much did she get last year? Jada, how much you got? 96? No?
It was a good mark, but...
Fantastic. Well done. Let's all give Jaden a nice round of applause, guys.
Woo!
Look how she's blushing here.
Fan club loading.
Here we go. All right. Okay. Let me not kill you now. All right. Now watch this one. Right. Shh. Take this one down. Put the heading there, inequalities. Now, very important. Very, very, very important, South Africa. Now, you know any number less than or equal to 0 is negative. You know any number greater than or equal to is what? Positive. Yes or no? So, pay attention. We're going to use pause or. What does that mean? Negative? X will lie between 2 points. It's positive. We'll use the word or. So let me show you. Let's start over the easy one. Baby work. But it's going to get a bit hectic. I'm going to show you some crazy stuff today. Because I know grade 12 says, give us meat. We want nyama. Give us the meat, Mr. K. Right, let's start with the negative one. So if we know x squared minus 2x minus 8 less than or equal to 0, we're starting with the negative. Shh, in your answer. Guys, remember something. Put your pens down. Whatever I explain, I'm not doing a rough calculation. You can answer it exactly the way I answer it on the screen. Copy and paste. The values will just change. So it's not about the values. It's about how we tackle it. Right, watch here. Remember, today is going to be shortcuts. So we're going to have x, we all know that, 4 and 2, minus, plus. What are my two critical values, guys? X minus 4 equal to 0, x will equal to 4. X plus 2 equal to 0, x will equal to... Right, so now all we do a rough parabola. Lower critical value first. It's like a number line, so the lower value first, higher value second. It's less than 0. Put down your pens. It's less than 0. Anything less than 0 is what? Negative. And where must x lie? What does bet mean? So put x between the 2 points. Copy and paste. X, 4, 4. Double click and drag. Double click and drag. Double click and drag. Copy and paste. And use the same sign. Boom. There's your answer. Final answer, no table, no number line, nothing, just use this neg bet. X lies between the 2 points. The arrows will point in the same direction. We all okay? Spine Road, we all right? Rocklands, we okay? Pandulwazi, I saw them coming there. Pandulwazi, are we all right there at the back? Let me see your hands. Wave your hands in the air, like you just don't care.
You're cooking with gas today, Mr. Coach.
Bro, we are moving on rocket fuel today.
Ethanol. Yeah, that's how we do it.
Jet fuel.
Did you give them an overview of what you're going to be covering today?
Yes,
okay,
we're doing
good.
algebra. We're going to be doing inverse functions. We're going to be doing functions. We're going to be eating calculus for breakfast. And lunch.
And what time is break time?
Because we started 30 minutes late, so we started at 11 o'clock. We're going to have to now push half an hour later. Right, let's go. You all did that one. So let's give you one more. To do. Right, 4x squared minus 1, or 4x squared less than 1. There we go, question, answer. Let's do this one together. So 4x squared minus 1 less than 0. Let's factorize that, less than 0. 2x minus 1, 2x plus 1. Your two critical values, x will equal to a half or x will equal to minus a half. All we do, I showed you this, we say minus a half and half. Less than 0 is negative. What's the rule for negative? Bet, neg bet. What does bet mean? So x must lie between. So x, half, minus half, use the same sign. Are we all good? You know how to do an inequality now? A negative inequality. Now we're going to do a positive inequality. And then I'm going to show you a cubic inequality when you got 3 values. Okay, that's the negative. Let's do a positive one. Let's say x into x minus 1 greater than or equal to 12. Easy one, easy stuff. Child's play, light work. Right, guys, let's all do it together. X times x, x squared minus x minus 12 greater than or equal to 0. Let's factorize that. So what do we have? X, 4, 3, minus, plus. What are your two critical values? Plus 4, minus 3. Boom, boom. Minus 3, 4. Yes or no, grade 12s? Right, now watch. Greater than or equal to 0 is positive. What's the rule for positive? Or. So put the word or, put x greater than or equal to, x less than or equal to. So for positive, the arrows point in the opposite direction. Why? Because greater than 4 is above, less than -3 is above. That's why the arrows point. It will always look like this. Take the bigger number, put it there. Take the smaller number, put it there. And we are done. Full marks. A problem like this in your exam? 10 seconds. Guys, grade 12, understand one thing. Your 3-hour paper, you got to finish it between 1 hour 45 minutes and 2 hours max. You finish your 3-hour paper in 2 hours. You must have 1 whole hour to check. Now, if you don't know your work, don't go write the paper. It's as simple as that. And those of you who are running out of time, and those of you who are leaving questions out, know it, internalize it, process it, embrace it. You're going to fail. Just be comfortable with it. Just tell yourself, I'm failing beautifully. Embrace it. Go party. Go tell your parents. Go lie. Go home when your parents ask you, how was the paper? Say, I smashed it. You know at the back of your mind, ooh, you got something else coming. Start finding alternate living arrangements. Right, watch here. Right. So now one of the questions that came out, check this one. I saw this one in a past paper. Y squared plus 4, y minus 3, y plus 2, less than or equal to 0. Solve for x. Solve for y. Okay. I'd love to put up the problem and give you a chance to do it. Unfortunately, it's a race against time. We're going to finish the whole year's syllabus in 1 day. So work with me. This is one big study session. That's all this is. This workshop is the largest study session in the country, in the world. There isn't another study session like this where everybody is sitting together on and on site, all doing the same thing. It's not happening anywhere else besides here. Shh. Watch here. Watch here. Watch here. Put down your pens. Critical values. Let's get our CVs on the side. So y squared plus 4. How do we get our critical values? We equate it to 0. Yes or no? How did we get our critical values? We took each factor and we equated it to 0. Yes or no? So watch here. So y squared is equal to minus 4. Y is equal to the square root of negative 4. Doesn't exist. Yes or no? Are you with me? Right, that doesn't exist. That doesn't exist. So now we got y minus 3 equal to 0. Y is equal to 3. That exists. Y plus 2 equals to 0. Y equals to minus 2. That exists. Again, 2 y values. 2 y values. Let's go there. Let's go there. Lower number first. Higher number second. Less than or equal to 0, negative. So y must lie between the 2 points. So y, 3 minus 2, use the same sign. But it's a fraction. Can y equal to minus 2? Can you get minus 2 plus 2 will give me how much? So can we have 0 in the denominator of a fraction? So minus 2 will make it undefined. So y cannot equal to minus 2. You can write it like this and then say y cannot equal to minus 2. Or just remove that 1 equal to sign. Say minus 2 less than y. It can be any number besides equal to minus 2, but less than or equal to 3. So you can write it at like that. or you can write it like that. Both are correct. Are you with me, guys? If you got a vertical value, your denominator 0, and remove the equal to sign from that. These are techniques, these are mathematical techniques to get you your A in math. I know we're drawing a parabola here, but what type of a graph is that? Y minus 3 over y plus 2. What type of a graph is that? Huh? Ha! We are in grade 12. We are in grade 12. Whoa, dude. And we say we are 2 weeks away from June exam and we say we prepared. How prepared are you? Guys, gauze. Right, let's talk like the guys from Camps Bay, hey? Right, gauze. So we have like x minus 3 over x plus 2, hey? Y equals. What type of a graph is this, hey, guys? Yay, my bro. Julle gaan jou gatte sien. What type of a graph is this? This is y equals a over x minus b plus q. Wallahi al-azim, by God. One of your exam questions is rewrite that as that and then give the asymptotes and then sketch. That's a grade 12 question. Some of you are bang already. You're already script now. You never saw this before. Right, let me show you how to do it. Just to show you. Put your pens down. So in your answer, you go y equals, you take the denominator and you copy and paste it on the top. So we got x plus 2. There's your denominator. We copy and paste it on the top, x plus 2. Now we have to rewrite it to look like that. So now we need to get a minus 3. So on the side, minus 2, plus 2, plus a certain number there next door must equal to minus 3. So the certain number will equal to minus 3 minus 2. So the certain number will equal to how much? So we take the minus 5 and we put him here. Now we split it up. So step number 1, copy and paste. That's step number 1. Step number 2, there we go, on my numerator, plus a certain number is equal to minus 3. So solve for the certain number. Minus 3 minus 2 is minus 5. There we go. Now split it up. X plus 2 over x plus 2 minus 5 over x plus 2. Here's your final answer coming up. Minus 5. There we go. A over x minus p. A over x minus p plus x over 2. That's 1. There we go. There's your answer. What's your equation of your asymptotes here? X is equal to minus 2. Q is equal to 1. Now we can sketch the graph. Make your face, Sunny. Take it down, learn it. So you guys came here to be vase. Right, grade 12s? Learn. Let's give you one more to do like this. Let's say y is equal to x minus 6 over x plus 5. Right. Rewrite that in that form. It's a hyperbola with a shift in asymptotes. Just trying to think, what did that diagram look like? Okay. So we had a graph, we had a graph, we had a graph, we had a graph. We had a point, we had a point. Oh, damn, I love maths. Yeah, ne? Are you done? Who's done with the next one? Let me see, show of hands. Come, it must be done quickly. If you're not done, you're not learning. You're wasting your Saturday. Do this one here. Can I erase the previous one? Are you ready? Y equals x minus 6 over x plus 5. Question, answer. Right, show of hands. Show of hands. How many of you are done? How many of you did it exactly like the previous one? Do you think you're right or you know you're right? You know you're right. Let's check. Let's check. So y equals, copy and paste, x plus 5 over x plus 5. Yes or no? Did you do that first? Right. Now plus 5 plus a certain number must equal to how much? So the certain number equal minus 6 minus 5. The certain number equals minus 11. So y equals x plus 5 over x plus 5 minus 11 over x plus 5. Y equals minus 11 over x plus 5 plus 1. How many of you got that one right? Give yourselves a nice round of applause. All right, so now you might ask the question, will that one always be 1? That's when you don't have a coefficient there in front. I'm thinking of something. All right, here we go. So I'm just showing you that this is a hyperbola with a shift in asymptotes. I'm showing you that that is a hyperbola with a shift in asymptotes. Okay, while I look for the other one, let's see you guys do this one. Solve for x. And now I tell you x plus 3 over x minus 2, or into x minus 2 over x plus 1 less than or equal to 0. Solve for x. Go for this one while I find you another one in that inequality with a coefficient in front. Do this one. I'm finding something interesting for you. Here we go. Right, let me show you how this one is done. What are your critical values here? -3, +2, -1. Yes or no? What type of a graph is it? 3x values. Can it be a parabola? No, parabola has only got 2. So this here is a cubic function. Pay attention. -3 there, that's your one. -1 there, that's your other. +2 there, that's your other. Less than 0 means below your x-axis. So where's your graph below your x-axis? It's below there. Less than 0 is negative, means below your x-axis. And it's below there. So put an x here, put an x there. Here's your one inequality, x2 -1 between the two. Or to the left, x less than or equal to -3. Can x equal to -1? No. So let's go to -1. And let's take away the 1 equal to sign. So we'll just have that. There's your final answer. There's your final answer. Now, if you look in your memos, your memo is going to give you a whole table of signs. Ignore. Don't use your table of signs. It will confuse you thoroughly. You won't know what to do. It will help you to fail. So stay away from it. You need to be in a position where you check the memo. You must correct the memo. The memo mustn't correct you. Right? Now, what if they made this one greater? So if negative means below, what would greater than or equal to mean? I can't hear you. Above. So let's do one with above. Let's do one with above. Let's make one up here sharp. What if I told you x plus 1 into x minus 3 into x plus 5 greater than or equal to 0? Go for that one. Come on, do that one. What's your critical values? -1, +3, -5. Boom. So what do we have? -5, -1, and 3. Greater than 0 means above. Where's your graph above your x-axis? There and there. Agreed, grade 12s? So we put an x there. We put an x here. So x -1 -5 less than or equal to less than, it's between the two, or to the right of 3, to the right of 3. X greater than or equal to 3. There's no fraction, so they're all valid. How's our onliners doing there, Khalid? Are they locked in? Are they winning? As always. I'm giving you one last inequality. Inequality is done. I'll throw you in with simultaneous equation. 1. I can't believe grade 12 still don't know how to do simultaneous equations. I marked papers last year. I had a shock of my life. Something that we take so much for granted that everybody knows. And yet they stuff it up royally. Right, the next one, watch this, grade 12. 2 to the power x into 3x minus 4 less than 0. Solve for x. How many here have seen one like this before? Nobody. Bravo, you guys at school this year. What happened? Onliners, how are we doing? How's our comments coming in there? Locked in. Life sentence. You locked into math for life, bruh.
And we got the gunnies that's on with us. Wait until the gunnies come on.
Pay attention now. We got two factors equal to 0. 2 to the power x less than 0. 3x minus 4 less than 0. Yes or no? Now, you are a grade 12 learner. What type of a graph is that? 2 to the x. Right. Can an exponential graph ever be below your x-axis here? Can 2 to the x? You know what does 2 to the x look like? What does 2 to the x look like? Doesn't 2 to the x look like that? Always. So can this graph ever be below 0? Can anything ever happen here at the bottom for the 2 to the x graph? So not valid. So all we do now, we say 3x less than 4, x less than 4 over 3. Final answer. Doesn't it? Why is it not valid? 2 to the x less than 0 does not exist. This 2 to the x is a positive exponential. So it's not valid. Less than 0 does exist. Smart, my bro. That's smart. It's from a past paper. So that means you haven't even started working through past papers yet. If you guys haven't mastered every past paper from 2018 to 2025, FYI, GS, Gatsin. Right, here we go. Right, so that one's done. Now watch here. I'm making up an interesting one. X squared plus y squared equals 52. Right, take this one down, solve for x and y. X squared. I'll make it even more interesting for you. Five marks. I'm not giving you your basic stuff. The basic stuff you can do at school, man. Why do you come here? This is what you came for. This is what you came for. Khalid, how's our onliners doing? Right. Okay. I know some of you are just smiling, such a beautiful smile, but you're screaming and the tears are flowing from inside. You ever saw a learner cry from behind their eyes? It's like those little kids, you know. The father smacks him so hard and he wants to show that he's brave, but he's crying from behind his eyes. He's swallowing his tears, you know. Right, watch. Right, grade 12s. Equation 1, equation 2. How do we get rid of the log? You got to put it into standard form. So you're going to say log x8 equals 3. Yes or no? Now pay attention. How do we get rid of the log? Right, if you know how to get rid of a log, pay attention. And make a note there on the side. This is how I get rid of a log. Pay attention. This is standard form. Log of a number to a base is equal to 3. This is what you do. You do what I call the smiley face or the winky eye. Okay, let's call it winky eye. Let's not call it smiley face. Let's call it the winky eye method. Don't tell your teachers this. Again, they'll ask you, what the hell are you talking about? It's just for us to understand. So we make a smile and then we wink. So we make a smile and then we wink across. So the winky eye. So let's go, Mr. Winky Eye. Let's start from there. Let's smile, x to the power 3, and let's wink across is equal to 8. You start from the base. Your power is your answer is your power, and then you come across is equal to 8. So what is x equal to? What's the cube root of 8? Sorry? 2. Now we take 2, substitute 2 for x in equation number 1. So we got 2 squared plus y squared equals 52. Y squared plus 4 minus 52 equals 0. Y squared minus 48 equals 0. So there's two ways of doing it. Squared is equal to 48. Y is equal to plus or minus root 48. That's it. You solve for x, you solve for y. Done. Done, done, like London. How's our onliners? Are they cooking? Are they on fire? Hasanain, talk to us.
This is the important thing. Very sorry. Shout out to Al Azhar High School in Athens. Mr. Mani and his cohort there.
Mr. Mani and his cohort. There's so many different pictures of schools that are coming in that are also setting up very similar to what we've set up here in different parts of the country. And they've got all their learners there. And we're beaming from here.
Social Movie High School. Mr. Clement, shout out to him.
We are done with this. I think, so guys, you know now how to remove a log. We're going to use the winky eye method. Yes or no? You want to try one more like that in a winky eye method? Just try it out. Let's say log x to base 2 is equal to 5. Right, solve for x. Come, this is easy. Do the same thing, winky eye. Start from the base to the power your answer is equal to your log. Come on, it's easy. 2 to the power 5, here's it, 2 to the power 5 is equal to x. X is equal to 32. Yes or no, grade 12? Okay, now here comes, now you want a crazy one, right? I know you guys love crazy shit. You're not normal. Did you ever think you guys are normal? I mean, when you look in the mirror in the morning, do you say like, I'm normal? Hell freaking no. The first part of healing is accepting. So embrace that you're crazy. Embrace it. Wake up in the morning, look in the mirror and say, here we go again. Here we go again. Come on, you guys know that song, huh? Don't you guys know that song? Here we go again. Do-do-do-dum, dum, dum, do-do-do-do-do. Okay, let's do maths. DJ Clock.
What's going on, Kota?
Well, it's Cape Town. It's the A. It's Cape Town A.
No, what's in that Lucasade bottle there?
Write that in the form y equal A over x minus P plus Q. Ew, they are crying. These are these internal cryings. How's our onliners?
There's a shout out from Spine Road.
Yes! Shout out to Spine Road High School.
Shout out to Miss Manuels. They say that she's the goat.
Shout out to Miss Manuels, the goat.
Someone is complaining here that you're ignoring her.
Who are we ignoring? Mariam Abrams.
It's Horeya. She says that, how does it feel being behind the screen and getting ignored by sir?
Sorry, man. Horeya, I don't get to see the comments here, brah. I got to turn around here and talk to Khalid, and I got to say, Khalid, feed me. On my computer here, I see numbers. Sorry, Horeya. Question, answer, right. I like how the grade 12 put their hands down and they just sit like this. You know what's it called? Clueless. Right, here we go. So this is, here's the art. Here's the art. So now we take x minus 1. We divide it into minus 2x plus 5. Pay attention. Here's the art. Bring up this minus 2. Now dividing, when you come this way, what do? You multiply and then you set. Am I right? You know long division from grade 5? You remember long division from grade 5? Ay, washlan niya. Washlan. So shy. Hey, what a time. We just vying and we motoring like it is no end to today. How about we settle 5 o'clock tonight? You want to keep to time? Let's keep to time. Yeah, let's keep to 10:30. Let's keep the time. No, we give them a 30 minute. Give them 30 minutes. Look. keep the time. Let's keep to the. They'll cry for more. When we're done with it today, they're going to say, go on, don't stop. Because they're going to see stuff today they never saw before in their freaking life. Give me more! No, okay, let's do math. Sorry. Right, let's go. So now when we come across, we multiply. So negative 2 times x is minus 2x. Minus 2 times that. And minus 2 times minus 1 is what? Plus 2. In grade 5, what would you do? Subtract, isn't? So when we subtract, what happens to our bottom signs? We subtract. So what happens to our bottom signs? They change. So that will become plus. That will become minus. Plus 2, minus 2x plus 2x gives me 0. Plus 5 minus 2 gives me how much? So it's got a remainder of 3. So f of x is equal to, you take that, minus 2 over x minus 1, and then this is your remainder, plus 3. A over x minus p, A over x minus p plus q. You want to try one on your own? Just one. Just one. So take this one down. This is the art. That's the process. So obviously, here you'll never be able to get your asymptotes from here. Your asymptotes is x equal 1, y equal 3, your p value and your q value. Now you can say, let x equal to 0 solve for y, or let y equal to 0 solve for x. Wabon. Right. All we do is dividing that into this. So here we go. Let's do it one more time. Same one. Same one without the frills. Let's go. Answer. So we're going to say x minus 1 into minus 2x plus 5. Yes or no? The girl who asked the question? Right. What do we do now? Right. We take the minus 2, we put it on the top. Agreed? Are you with me? Now we multiply. Minus 2 times x, minus 2x plus 2. Subtract. So that will become minus. Now we just add it. Minus 2 to 0. 5 is y, or f of x, is equal to minus 2 over, that's your a value, x minus p plus q. Thumbs up? Like a boss. Right. How much time do we have? It's 10:15. Let's erase this. We got the last 15 minutes. Let's go into inverse functions. No. Before we do that, let's give you that crazy Hugh. I came across that one this week, bruh. Let's do it. Take it down. Take it down with me. Okay, wait, I'll tell you when to take it down, right? So we got a graph going like that. We got a graph going like that. Right, this is graph F, right? Then we got graph G. Okay, give me a second. This is given to you in your exam grade 12. You better learn this. You better see this. Otherwise, you're going to see stars in your exam. I'm going to give you another graph. The other graph is going to cut like this. That's graph G for green. Right, f of x is equal to a over x plus p plus q. That's a K. You're on the top, that's a K. Give me a second. So I would say G of x. Guys, sorry, make it G of x is equal to a over x plus p. Wait, give me a second. Yeah, so we got point A there. I'm just going to put G of x is equal to a over x plus p plus q, and f of x is just a over x. A over x. That's not a 9, that's a A. Right, so f of x equal a over x, g of x is equal to a over x plus p plus q. Right, here we go. This is what we're going to do before break. Question number 1, I want the coordinates of E. Question number 2, I want the coordinates of A. Question number 3, I want the equation of G. Right, mark allocation, 2 marks. Coordinates of A, 2 marks. The equation of G, 8 marks. Hey, Mango Fish! My guy is in the house. Where's he from? Where's Hamza? Hamza Lunat is in. Mango Fish all the way from KZN. And I know Mango Fish, he was one of our top students for 3 years from grade 10, top student grade 11. I think he's also going to get 95 to 100 this year. I got a couple of potential 100%ers in mind. What's the coordinate of E? E lies on graph. So you know what we should have done? E lies on F. Yeah, E lies on graph F. So to answer question number 1, that's X, that's Y. So it lies on graph F. So we're going to say f of x is equal to a over x So what is... No, okay, so now we're going to... sorry, we should have made this -4. We should have given you that, am I right? No. Because then K equals A over -1. Oh, NOS. NOS, NOS. It shouldn't have been 2 marks. I think the first one should have been 4 marks. Make that 4. 4 and 2 is 6. 6 and 8 is 14 marks. Beautiful. Right, in order to get E lies on graph F, but I don't have the equation of F. Can I find the equation of F? Yes, I can. There's a point on it, -2 and 2, yes or no? Guys? Now let me show you a shortcut. F of X is equal to get the A value on a standard hyperbola. On a standard hyperbola, just multiply these two together. -2 times 2. -4 over X. So there we go. That's your equation of F. Shh. I'm showing you a shortcut. A little hack. So for a standard hyperbola, you can take any point of coordinates and you just multiply the two, will give you your A value. For a standard, you want me to repeat that for you? For a standard hyperbola, you can take any pair of coordinates that lie on there with using B, and you just multiply these two. -2 times 2, -4. Now we find E's coordinates. K equals -4 over -1. K equals 4. So that means E's coordinates is -1 and 4. That's your first 4 marks. Right. Are you following, guys? Step number 1, we found F of X. Step number 2, we put in the X and Y. That's Y, that's X, the coordinates, X, Y. K is equal to 4. Right, now we go back here. So we got K is equal to 4. And we know A is equal to -4. Don't forget that. A is equal to -4. Can I erase? Do number 2. What's the coordinates of A? What's the coordinates of A? A lies on the axis of symmetry. So it's a reflection of this point. So what is this? If this is -2 and 2, what is this? 2 and? Aha! Okay. Now for the 8 marks. Okay, Lenas. To the last one. She's worth 8 marks. If you do not get the last one right, you will be failing this whole topic in your exam. Now, I guess you want me to help you, right? The equation of G. We're moving on fantastic time, although we started 30 minutes late. MashaAllah, tabarakallah.
Mr. Kota, back in the day, we used to start at 9 o'clock. So if you're running behind time, you are screwed. but this time we've got some wisdom, divine wisdom infused in us, so we've got that buffer. Learners, just one reminder, we will be feeding you during lunchtime. The rules is as follows. You may not leave the premises. If you are leaving, au revoir. That's it, farewell to you. You would have to stay within the premises.
Security reasons, guys. We don't want any incidences taking place. I don't need to tell you. Right. Now we got g of x is equal to, because it's the same a value here, it's also minus 4 over x plus p plus q. Right, now we want the equation of g for 8 marks. I got 2 pairs. And we got another point here. Now what if, all right. Okay, we don't have another point. Must we use both these points here like this? Must we use minus 2 and 2 and 2 and 2? Alternatively, I could have given you also another point here. Let's say we gave you, because I'm trying to pick this one out of memory. So I'm thinking, because I can't put this. Oh yeah, no, this one for, no. I need a point on G. I need a point on G. So let's say there was another point on here. Let's call it point, I don't know what you want to call it, point N. Let's give it another point, and let's say that's minus 6 and 5. Just for example. Just for example. I think I left out a point on there. Right, so we got a point here. We got another point on graph G. Oh, I think they gave another point on graph G. Okay, but it's fine. It's fine. We're making it up. The coordinates are not important. What's important is the procedure now. Right. So let's call this coordinate 1 and let's call that coordinate 2. And now we're going to use simultaneous equations. So let's use n's coordinates. Let's use n's coordinates minus 6 and 5. Right, put it into there. So 5 equals minus 4 over minus 6 plus p. But that can't be 5, né? Because that's 2. Remember, that's 2. This point is going to be less. So make it this point here is minus 2 and 2. So make that minus 6 and 1. Let's just change this one, guys. Let's just change this. Let's change that. Make that a 1. Just change that one. Make it minus 6 and 1. Make that minus 6 and 1. Right, so 1. 1 equals, let's do this. Let's change it there. Plus q. Right. That's if I put n's coordinates. Now I need another point on graph G. And what other point do I have? 2 and minus 2. So now I'm going to use A's coordinates. Right? I'm using A's coordinates. So let's put in A's coordinates in here. Minus 2 equals minus 4 over A, the x value here is 2 plus P plus Q. Equation number 1, equation number 2. Let's now solve for P and Q. Now comes the algebra, guys. So we're going to subtract the two equations. Why am I subtracting? To get rid of the Q. So that will become a positive. Remember, all your bottom signs will change. Bottom signs change because we subtracting. So that will become a positive, that will become positive, and that will become a negative. So we subtract it. Now we just add it like normal. Plus q minus q will give me 0. 1 plus 2 is 3. You got minus 4 over p minus 6 plus 4 over p plus 2. Yes or no, guys? Grade 12s. Are we hitting the heavy notes today, brah? Hassanin, we are hitting the heavy notes.
You slept well last night, eh? You energized, young man.
2 this morning.
Oh my. But what's in your bottle there? It's like ethanol or rocket fuel.
Good shit.
Puff and pass.
This is good shit. Like math. Math is good shit. Are you done? No. You are even fighting to solve for P. Yay. You'll fail, brah.
Shout out to Mariam Abrams.
Right, let's go. Let's do the algebra. I'm going to multiply everything by p minus 6, p plus 2. Let's go. Let's have fun. So 3 into p minus 6, p plus 2 will equal to p minus 6, p minus 6. We left with p plus 2 times minus 4 into p plus 2. Then p plus 2, we left with p minus 6 times 4 plus 4 into p minus 6. So we multiply every term by that common denominator. So 3 into p squared minus 6 plus 2 is minus 4p minus 12 equal to minus p minus 8 plus 4p minus 24. So 3p squared minus 12p minus 12, 24, 36 is equal to minus 4p plus 4p is gone. Minus 8 minus 24 is minus 32. P squared 12p minus 36 plus 32 equals 0. 3p squared minus 12p. That right. And now P equals or P equals. Go to your factorizing calculators. I hope you got your factorizing calculators. So now go to your calculators, your FX 991s, the ones that factorize. Okay, I don't have it here, but I'll use my phone. FX 991, boom, 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 mode, AX squared. You can use even the quadratic formula if you want. 3 equals minus 12 equals minus 4 equals. I get minus 0, 3. Or I get 4, 3. Now remember, your P value here, if you're going to put in plus 4, 3 will be minus 4, 3. If you put minus 0, 3 will be plus 0, 3. So it's going to be plus 0, 3 because for graph G, your asymptote is here. That's where your asymptote is. So we can't use 4, 3 because now we're going to put in P. Remember, you're now going to get G of X is equal to minus 4 over X plus P minus 0,3 plus q. So obviously if it's minus here, it would be plus here. That's 0,3. And now you can just solve for q. You can put in the p value into here, and you can use any pair of coordinates and now solve for q. And game over. It's 10:36. It's 10:36. Boys and girls, you guys have been absolutely amazing. We had a bumper session first half. I think we need to give you all need to give yourselves a nice round of applause for sitting in. Guys, you got a break now. Listen, we got a break. 10 past 11, you walk back in. 11, we start. We're starting with inverse functions. Functions and inverse functions, and then calculus. You don't want to miss the next session. 11, make sure your ass is grass. Make sure that your bums are on your seat. Assalamu alaikum. See you guys. 11, we restart. Guys gonna mess around, or if your mind, you distracted somehow, you've just lost today. And today, some of the most valuable concepts are explained to you. Things you've never understood before, today, hopefully you will understand. When you leave here, you've got to have such a clear picture of math that you must be ready to write your June exam on Monday. That's Monday. That's the purpose of this weekend. So pay attention. So let's all work together. F of minus 1, swap, that's y. Swap the x and y. X is equal to 4y minus 10. Don't tell me I'm moving too fast. Really? This is baby work now? Let's make y the subject. So 4y is equal to x plus 10. Y equal, divide by 4, a quarter x plus 10 over 4 is 5 over 2. So f of minus 1x is equal to a quarter x plus 5 over 2. Yes or no? I don't want to put the x there, so you might get confused. Put it on the top. It never goes at the bottom. A quarter x plus 5 over 2. There we go. Basic one. Now you're all smiling because you know what to do. Now comes the hyperbola with the shift in asymptotes to give its inverse, then the parabola and its inverse, then the exponential and its inverse, which is the log. 100% you're getting tested on. Absolutely. Have no doubt. If you don't get tested on this, there's no function. Let's go. So that's a straight line. Now watch here. Watch, to show you a shortcut. Now it's time for some shortcuts and some hacks. So if I told you h of x is equal to 4 over x minus 1 plus 2. Now watch here. Let me show you a hack. H of minus 1x is equal to, check this one out, 4 over x minus plus. This is the inverse function. All you do, you swap the p and the q. Bring the 2 down, bring the 1 up. Done. You don't need to swap x and y, make y the subject. I'm showing you a shortcut of doing it. But this is when the two signs are different. When the signs are different. Positive, negative. But what if I told you g of x is equal to 4 over x minus 1 minus 2. Now what happens if you have the same sign? Now what do? You do g of minus 1x is equal to 4 over x plus, and you swap the 2 and 1. So when the signs are different, you leave the signs and swap P and Q. And here, when it's the same signs, then you change the sign and swap. Learn this. These are rules. These are little shortcuts. These are hacks that's going to make you finish a 3-hour paper in 1.5 hours. Nabila, I'm in a workshop. Right, so that one, I don't know what's happening here. Just hold for me a second. I think the onliners there, Asanain, are we back? Are they back? They couldn't see the screen? Are they back? Is it fixed? Onliners are sending me a message. Okay, let's just check. Let's just check. Let's just check. Okay, sorry about that. Onliners, we are back online. I hope you guys can see the screen. Everybody all okay? Here we go. So let me repeat this for the onliners. If you've got different signs, you keep the signs, you leave or you keep the signs, and then you just swap the P and Q. Bring the 2 down, bring the 1 up. If you've got the same signs, then we change the sign. Negative becomes positive, and then we swap the 2. Swap. What do we swap? P and Q. There's your inverse function. Done just by looking at it. You don't need to swap X and Y. You save him. The aim for you in the exam is to save. You want to finish the 3-hour paper in how many hours? 2. 1.5 to 2 hours. With mastery, not 1.5 hours leaving half the paper blank. Some of you will say, no, Mr. K, say finish it in 1.5 hours. So let's leave the whole paper blank. You'll fail nicely, beautifully. Right, now watch. The next one. F of x is equal to 2x squared. No restriction given. What graph is this? Parabola. Astaghfirullah. Don't you ever say exponential. Yirr. That's suicide, bruh. That's a kamikaze move. Damn. Exponential. My foot. Right. How do we? Let me show you a shortcut. Here's a shortcut. Let me show you a shortcut. F of minus 1x is equal to. What does the word inverse mean? Right. Pay attention. What's the opposite of square? Square root. So don't we say plus minus? Yes or no? Guys, what is the opposite of square? Square root. What is the opposite of 2 over 1? And what am I left with? That's your answer. In one line. Let me give you another one. G of x is equal to minus 3. Let's make it minus 1/3 x squared. Right. What is g of minus 1x equal to? Plus or minus the square root of negative instead of 1 over 3 over 1 x less than or equal to 0. You must put this restriction. Why? If x is negative, negative times negative is a positive, so it will exist. You can't have x greater than 0. Because if x is a positive times a negative is a negative, we can't get a square root of a negative. Are you all with me? Right. Now pay attention. You're getting tested on this. 100% you're seeing it in June, prelim, and finals. Right. So let's erase this. Now watch. Okay, let's go. Boom, boom. F of x is equal to minus, okay, let's say 2x squared. Right. Question number 1. I want the inverse of f in the form f of minus 1x equals. Question number 2. Sketch both graphs on the same set of axes. Is the inverse of f a function? And the last one is, how will you restrict the domain? How will restrict, I'm going to write it right here, restrict the domain of F in order for F of minus 1 to become a function. Four questions. F of x is equal to 2x squared. That's your question. Answer to question number 1. The inverse of f. So f of minus 1x is equal to plus or minus the square root of 1 over 2x. Yes or no? Correct. First 2 marks. Sketch both the graphs. So let's sketch the graphs. Let's sketch the graphs. They just want to see that you know the shape. So let's sketch f of x, 2x squared. So 2x squared goes like that. There's no y intercept. That's graph f. It's pointing to the positive y. Right, the inverse. If the original is pointing to the positive y, the inverse points where? No, not negative, my child. If it's pointing to positive y, it must point to the positive x, not to the negative. Is the inverse is f of minus 1. Guys, are you all following? If the original h of x was equal to minus 3x squared, then your graph would have went like this at the bottom. Minus 1 would have went in that direction. That's h of minus 1. That's h. Can you guys see? Positive, negative. Right. Let's answer question number 3. Is the inverse of f a function? Is this graph here? Is that graph a function? No. Why? If you do the straight line test, for one x value, you get more than one y value. So you'll say no, because it's a one-to-many relation. One x value to many y values. Okay, you going? You're off. Okay, we good. Sure. How will you restrict the domain of f in order for f of minus 1 to become a function? How will you restrict the domain of the original one, of this one here? So basically, how will we do it? We can say for x greater than or equal to 0, the positive part, then I'll have a positive. So you'll say, to answer question number 4, you'll say for x greater than or equal to 0, or if I did the negative part of this graph for x less than or equal to 0, if I restricted the domain x less than or equal to 0, you do the negative part of the positive graph. So the negative, that's the negative part, that's less than or equal to 0, the negative part of the positive graph. So you're going to have now the negative part, which is a function, or for x less than or equal to 0. Those are your two solutions. For x greater than or equal to, that's how you restrict the domain. What? A Bluetooth device is connected as successfully. Right. So now let's talk about this a little bit. Right, let's see how sharp are you now. Okay, I want you to sketch. Let's see how sharp are you. Come, let's make one. Let's say h of x is equal to minus a third x squared for x greater than or equal to 0. Right, number 1, give the inverse of h in the form h minus 1x. Sketch both graphs. There we go. Question, answer. Or actually in sketch, this one here just says given. Right, you given h of x is equal to minus a third x squared, x greater than or equal to 0. Give the inverse. Let's do it together. H of minus 1x equals. Now watch here. This is the interesting part. Put your pens down. Grade 12, put your pens down. Let me explain it to you. Right. We know x greater than or equal to 0. So what is this? Isn't that your restriction? Yes or no? And greater than or equal to 0 means? So you know where you put this positive? Outside. The restriction comes outside. The opposite of square is square root. You leave the sign inside. 1 over 3 becomes 3 over 1x. There we go. So the outside, very important. I want you to remember this. Remember, the outside sign is your restriction. Your original sign goes inside. Now let's draw the graphs. This is a negative parabola. Let's draw h of x. It's a negative parabola. But they want the positive part. That's the positive part. That means this side we erase. Now it's a negative parabola, so the inverse would be a negative inverse. But we only want the positive part. That's the positive. We only want the top part of it. That means the bottom part we erase. And there we go. That's what your graphs look like. So we gave the inverse. That's a mark, 2 marks. Sketch both graphs. You'll get a mark, you'll get a mark. That's another 2 marks. Total marks here, 4. Are you with me? Grade 12s? Remember, I promise you, you got to master, not just remember, you've got to master this. Right. Now we go into the exponential and the log. The inverse, brother and sister, they from the same family, but they are different. Where exponents ends, logs takes over. It's like husband and wife. Where the one shuts up talking, the other one just continues forever. So I think exponents must be the husband. He's got to shut up. The wife will just go on for infinity. Well, women are evil, bruh. Yeah, they're psycho. You guys know women are evil, ne? You know woman equal time times money. You know that, ne? And you know, but time equals money. Yes or no? Therefore, woman equal, instead of time, what can I put? Money times money. So therefore, woman equals x times x is x squared. So money times money is. But we also know that money is the root of all. So we can say woman equal, instead of money, I can put square root of evil squared. And you know that the first rule of math is the square and the square root cancels out. We've just showed you now mathematically that woman equal Satan. Well, the mathematics says it all, brah. The maths don't lie. The numbers don't lie. Oh, now you want to write this very fast. But when I write a maths problem, you don't want to write it. The numbers don't lie. All right, let's go. And that, ladies and gentlemen, is why my wife left me. I'm lying. Right. Exponential. Right. Learn this. Y equals 2 to the x. Y equals half to the x. So y equals 2 to the x, positive exponential. Y equal half to the x, negative exponential. We know that a positive exponential goes like that. Going through which point? Whenever x is 0, any base to the power 0 is how much? 1. And the negative exponential, y equal 2 to the minus 1 to the x, y equal 2 to the minus x, that graph goes like that. And that also goes to the point 0 and 1. That's your x-axis, that's your y-axis. Very important. What do we notice about both of them? So all standard exponential graphs. Learn this, memorize this. Number 1, have only one y-intercept. Have only one y-intercept. What is it? 0 and 1. Number 2, your x-axis is your asymptote. What's the meaning of the word asymptote? A line which your graph never touches. Yes or no? Good. If you don't remember it, you know the abbreviation for asymptote is S. You know in life you can't go around touching someone's. So you know when it's an asymptote, never touch. Haram, Jahannam, hell. Many of you don't know the difference between asymptote and axis of symmetry. Asymptote is a line which your graph never touches. Axis of symmetry is mirror image line. Number 3, what is the equation of your x asymptote? Y equals 0. Right. This of your x asymptote is y equals 0. The domain for both graphs, any x value will give you a y value. Whenever we say any, we say x is an element of real numbers. And range, which y values? It's all your positive y values. So y greater than 0, y is an element of real numbers. Yes or no? What are your rules of action? So 1, 4, let's go into your reflection rules. Let's go into rules of reflection. Remember, I'm filling your toolbox. I'm making sure that you know every rule in math. What are your rules of reflection? So if we got y equal 2 to the x, if we reflect it, how many rules do we have? If we reflect axis or the y-axis, what when you reflect something about the x-axis? The y sign changes. About the y-axis, x sign changes. Line y equal x, they swap over, signs don't change. And what is this? About the line y equal x for the exponential is the log graph, is the inverse. Whenever you're reflecting a graph about the line y equal x, it's the same to make y the subject of the, so it's the inverse. So the inverse of a graph, the reflection about the line y equal x is the same thing. How's our onliners doing? It's fine, I'll Uber. Okay, you guys done? How about rotation? Do you guys remember rotation? Rotate 90 degrees, anti-clockwise, clockwise. What are the rules? Forgot it? Must I give it to you? You want it? Astaghfirullah. Let's go. Rotation. Let's take the point P, 2 and 4. You get rotation, 90 degrees anti-clockwise, 90 degrees clockwise. You get 180 anti-clockwise, you get 180 clockwise. It's very easy. Oh, wait, let's just quickly do, okay, you know how to, so here's rotation. 90 anti becomes P dash. The 2 swap over, 4 and 2, but the x changes. So you swap and the x sign changes. Clockwise, you swap the original, but the y sign changes. 180 anti, 180 clock. They stay the same. In the same position, stay in same position. Both signs change. Guys, today and tomorrow you're rewriting your own study guide. Today and tomorrow you're writing your own study notes that you will be referring to about a topic. You stuff it up, you're only stuffing up your own future. Nobody's going to give you these notes. Nobody's going to recap all this for you the way we're recapping it for you now. And we've got 2 days now. We got another 2-day workshop like this before prelim and another 2-day workshop like this before final. By then, you should be acing it. You guys should be acers in math. Clapping it left, right. Have you all taken this down? Got it? Right. Let's go into the log. Now, this is now we're ending up now on functions. We are ending up on functions. Guys, I'm not going to do the grade 11. That's not what I'm here to do. So I'm not going to give you a parabola and give you a straight line and ask you to find the equation of a parabola. Bruh, that is grade 11 work. You got to know it, but it's not for today. Today I'm doing grade 12 content. Right, watch here. What did we say? Log graph. So let's say h of x is equal to 3 to the power x. Question number 1, I want the inverse of h in the form h of minus 1x equals. Number 2, sketch both graphs. I want the domain of h of minus 1. I want the range of h of minus 1. I want the asymptote, the equation of the asymptote of h of minus 1, for which value of x is h of minus 1 less than or equal to 0. That's given. Let's answer question number 1. Take that down. Let me bring this slightly down. There we go. H of x is equal to 3 to the power x. That's what's given. You ready? Grade 12s, are you ready? Right. So h of minus 1x is equal to, what's the inverse of an exponential? A log graph. So you say log base 3x or log x to base 3. Number 2, sketch both graphs. So 3 to the power x is a positive exponential. So it's going to go like that. And it's going to go through 0 and 1. The inverse function is a positive log coming down like that. So this is graph h, this is h of minus 1, and that one is the inverse. So what's the opposite of 0 and 1? Very good. So there we go, we sketch both graphs. The domain of h of minus 1, which x values here? So answering question number 3, the h of minus 1, x greater than 0. All your x values, all your positive x values. The range of minus 1. H of minus 1, the range, all your y values. So it's from negative infinity to positive infinity. Or you can say y is an element of real numbers. That's all. Number 5, the asymptote, the equation EUT and the equation of the asymptote. So now, which line will h of minus never touch? Which line? The the y-axis. And what's the equation of your y-axis? Equal 0. Agreed, guys? For which value or values of x is h of -1 negative? Can I erase number 3, 4, 5? Got it down? Good. Right, let's go. Where is the where is the negative below your x-axis there? So for which values of 0 and 1? So to answer question number 6, we're going to say for x, although there's an equal to sign, so less than or equal to 1. But we can't say equal to 0 because that's our asymptote. We just say but greater than 0. Or you can say from 0 to 1, 1 square bracket because it's included. 0 not included, so you can put a round bracket. One is written in interval notation, the other one is written in inequality form. Both are acceptable. Right, guys? Good. Let's wrap up with functions before we hit calculus. Okay. I'm just thinking. Right, let's go. So guys, that is your function. We okay with inverse functions? Lovely. Let's start off with calculus. Right. What do we need? Now, calculus, when we find the derivative, we are finding the general gradient on a graph. That's what the word derivative means. The word derivative means you're finding a general gradient. You know for each line, we use y2 minus y over x2 minus x1. But for any other graph to find the general gradient, we use calculus. That's all we're doing. Whenever we are finding the derivative, what are we finding? The general gradient on a graph. Now, there are ways of finding the derivative. The first way is first principles. And that is by using the formula, the calculus formula. Then you have the second way to find the derivative or to find the general gradient is what? The power rule, the shortcut. And then we have differentiation, which is the same as finding the derivative, differentiation. And what's the meaning of differentiation? It's finding the derivative. It's finding the derivative, the general gradient, for more complex functions or equations. Take this down. Okay? I'll do one example. I'll give you one. We'll do one more. We'll do 3 examples of first principles, and I promise you, you'll all get it right. But you have to follow the template. You have to follow the structure. You have to follow what I'm about to show you. Step by step. You do it, you're going to fly in calculus. Calculus of 1. 40 marks out of 150. Almost a third, 28% of your paper, 30% of your paper is calculus. Right, now pay attention. I know many of you said you don't understand calculus. Well, now is the time for you to pay attention. Right, so let's start. We're starting with first principles. So guys, watch here. I'm showing you something. Put your pens down. Put your pens down. You know f dash x is equal to the limit as h approaches 0, right? What does that mean? It means the maximum distance that a secant will travel until it almost becomes a tangent. A tangent touches at one point, a secant touches at. So you want to find what's the maximum distance that that secant will travel until it almost becomes a tangent, right? Given by f of x plus h minus f of x all over h. Now, maybe some of you know this, maybe you don't. This just means your general gradient. So from y equal mx plus c, what's your gradient? Your m value. Yes or no? Pay attention. And this here is y2 minus y1 over h is x2 minus x1. It's the same formula. Did you know that? You didn't. Okay? You want to enjoy calculus even more. You want to enjoy calculus? I'll show you something. So now, before we get into that, let me show it to you, please. Yeah? Check here. Check this out. Let's say you had a parabola, that's f, and let's say the secant, any secant, straight line. And let's say that is point A and that is point B. We want to find out what is the gradient of the parabola. Pay attention. So that means we don't have this value here. We'll just call it x. And its y value is f of x. This b value is x. Between here and here is h. The distance here is h. That means the b's x value would be x plus h. And its y value, what would the y value be? F of x plus h. So let's call this x2, y2. Let's call that x1, y1. So to find the general gradient of the parabola, we say f dash x, the derivative, is equal to y2 minus y1 over x2 minus x1. So f dash x is equal to, what's y2? F of x plus h minus, what's y1? F of x over what's x2? X plus h minus what's x1? X. Plus x minus x cancels. What do I find? F dash x is equal to f of x plus h minus f of x all over h. It's the same as y2 minus y1 over x2 minus x1. And all we're doing is we're finding out what's the maximum distance that that secant can travel. So why do we say? We say the limit as my secant approaches 0. Why? If between the 2 points, you say 10 units, smaller, line is going to travel 9, 8, 7, 6, 5, 4. What number is it approaching? 0. That's all that it means. But it's y2 minus y1 over x2 minus x1. You're not writing on this. I'm making you enjoy. I'm making you understand what the word first principles, derivative means. It just means gradient. That's all. We're finding. So when we find the derivative, we are finding the general gradient at any point. On any graph, not the parabola. On any graph. And listen, another word for derivative. Remember the power rule, we minus 1 from the power, ne? Yes or no? You know what's another word for derivative? What's another word for derivative? How many of you do physics? How many of you see ms to the minus 1 when you subtract from the power? Another word for derivative is speed. And another word for speed is A. Another word for second derivative. Another word for second derivative, ms to the minus 2. Second derivative. How many of you do physics? What is that called? Second derivative, point of inflection, point of concavity, point of acceleration. First derivative, when we're finding it out, we're finding the general gradient, we're finding the dash speed. Let's have fun. Now we start with calculus. That was the intro. I love it. Welcome to calculus, guys. The world of calculus. Right. If f of x is equal to 4x squared minus 3x, find the general gradient by first principles. Right, pay attention, 5 marks. How's our comments coming in? Yo. Right, let's go. In your answer, we got f of x. So the first thing we do is we find f of x plus h. Please do it exactly the way I do it here. So now for every x, I put x plus h. So 4 into x plus h squared minus 3 into x plus h. Remove the brackets. 4 into x squared plus 2xh plus h squared minus 3x minus 3h, which is equal to 4x squared plus 8xh plus 4h squared. I'm multiplying it out, minus 3x minus 3h. That's step number 1. Do not That's it, I'm leaving. It's time to go home. Call it the day, man. Let me just go. Get me a plane, man. I'm going to Free State, rather. Yo, I think even the mic is getting scruck here, brah. Right, so here we go. That's step 1. Step 2, go into your formula. You get a mark for it. F dash x as h approaches 0, f of x plus h minus f of x all over h. So the limit as h approaches 0, f of x plus h, copy and paste. Highlight it, copy and paste, 4x squared plus 8xh plus 4h squared minus 3x minus 3h minus f of x. So change both those signs. Minus 4x squared plus 3x all over h. 4x squared minus 4x squared plus 3 minus 3x plus 3x. Now what do we do? The limit as h approaches 0. You continue at the bottom. I don't have space. I'm moving to the side. Take out h to cancel this h. So h into, if I took out h there, what am I left with? 8x plus 4h, 3 all over h. H and h cancels out. Now you say, but h approaches 0, therefore f dash x is equal to 0 times 0. What am I left with? And that is your final answer. Done. Done. Finish. Enough. Your first 5 in calculus. I heard some of you are battling with first principles. If you are battling with the opening topic of calculus, stay at home. Don't go write your exam. You're going to make a fool of yourself. Right, we're done with this. Want to try one like this on your own, okay? How many of you say move on? Move on. Some of you not. How many of you want me to do one more example, or you want to try one like this? No. You don't want to talk to me, I might as well do it. Right. Here we go. Here we go. Here we go. Right. What happened here now? And now? Give me a second. Right. F of x is equal to minus 2 over x. Find f dash x by first principles. Now we have to use the formula here. Answer. So the first thing we're going to do, we're going to find f of x plus h, which is minus 2 over x plus h. Therefore, f dash x is equal to the limit as h approaches 0, f of x plus h minus f of x all over h. Right, what's f of x plus h? Minus 2 over x plus h. Minus f of x. Negative is a negative x. Divide over 1. Put it to the side so you don't work with a fraction over a fraction. So this would be, let's work it out, the limit as h approaches 0. What's my LCD here? X into x plus h. So that and that will cancel. We left with x times minus 2 is minus 2x plus x and x will cancel. X plus h times 2 is 2 into x plus h. All I'm doing is the LCD times 1 over h. Let's remove the brackets. This is equal to the limit as h tends to 0 minus 2x plus 2x plus 2h all over x squared plus xh times 1 over h. Now that and that will cancel out. The h and the h will cancel out. I'm left with the limit as h tends to 0. I'm left with 2 over x squared plus xh. Now we say, but h tends to 0. Therefore, f is equal to, you drop the limit. What am I left with? 2 over 0 times x is 0. What am I left with? 2x. Are you with me, grade 12s? And practice on it over, over, and over until you get it right. Guys, you have got to go home and practice and master. Right, now let's start with derivative, the power rule. So this is first principles, the long way, the formula way. And if they do it by first principles, you have to use the formula. Guys, those of you that didn't understand first principles, are you understanding it now? Formula f of x plus h, it into your formula. At the end, insert h. Only at the end. Agreed? Let's do the derivative, the power rule. Let's put the derivative. Now the derivative is the power rule. Now if I told you f of x is equal to 5x cubed minus 6x squared plus 10x minus 8. Pay attention. It can be written like that. It can be written like 5x cubed minus 6x squared plus 10x minus 8. It could be written like that. Or it could be written like this, dx 5x cubed minus 6x squared 10x minus 8. They are all the same thing. But they are different. It's the same rule we apply. It's the same rule we apply, but only different formats. Please remember the format. So let's do them all quickly. So here, when we're finding the derivative, the question will say find f dash x. Here, the question will say find dy over dx, the same thing. Here, the question will say differentiate, the same thing. They all mean the same thing. Pay attention. So here we say f dash x is equal to, what's the power rule? I'm sure you all did this now. Power times coefficient minus 1 from power. Three times 5 is 15. X to the power 3 minus 1 is 2. 2 times minus 6 is minus 12. X to the power 2 minus 1 is 1. 1 times 10 is 10. X to the power 1 minus 1 is 0. X to the 0 is 1. What's the derivative of a constant? 0. Why? Because a straight line got no gradient. Minus 8 is a straight line, and a straight line got no gradient. Yes, question? What's the time now? Yo, it's 20 past 12. Are you guys hungry like? One o'clock. 1 o'clock lunch. Lunch guys are here. They feeding you. Right. Here we're going to say dy over dx is equal to 3 times 5, 15x squared, minus 12x plus 10. Here, you say is equal to 3 times 5 is 15x squared minus 12x plus 10. You must answer it in these formats. So that's derivative. Power rule. Now we're going into differentiation. The process of finding the derivative for more complex functions. Right, put the heading differentiation. So we are also finding the derivative. And we do it in 3 parts. Differentiation, differentiation, after differentiation. Before execution, during execution, after execution. Right, before you get the express straight line, you use algebra to simplify. Derivative, power rule. Then you apply power rule. That is step 2. After differentiation, you write your answer with positive powers. Now we're going to do a couple of examples. I'll give you different, I'll give you about 5 or 6. We'll do them together. You master these. You can do any from any paper. Templates. Guys, this is how I got 100 in grade 12. From failing in grade 11 to getting 100 in grade 12. I made templates. I mastered it. I memorized it. There was nothing that could beat me. I got 100. Right. Let's go. Type 1. Check this one out. If I tell you y equals x squared minus 2x minus 15 over x minus 5. Pay attention. Right. Type number 1. We need to get it BDA. So that's the question in your exam. Answer. The question will say find dy over dx. So type number 1, we got 2 terms. So in algebra, what do we do in type number 1? We factorize and cancel. So watch here. So we can say y equals, let's factorize that, x, 5, 3, minus over x minus 5. That's algebra. Y equals, not dy over dx. You're still simplifying y. X minus 5, x minus 5. What am I left with? Therefore, so we did that. Now we apply the power rule. dy over dx is equal to 1 times 1 is 1, x to the power 0. What's the derivative of a whole number? 0. 1 times 1 is how much? 1. That's your final answer. Right? Let's see how sharp are you. Let's see how sharp are you. Another example of this. These are all exact questions, guys. Let's say y equals x minus 1 over root x minus 1. Find dy over dx for 4 marks. Question, answer. How do we simplify? What you say? Guys, pick this up. Check this. When you got 2 terms here, I'm helping you to think smart, man. That's what you came here for. To think smart. This here is the difference of 2 squares. Is root x minus 1 over root x plus 1. That's that. Over root x minus 1. Never saw that one coming, did you? That's the difference of 2 squares. So now that and that cancels out. So y equals root x plus 1. Y square root x is what? X to the power a half plus 1. Yes or no? Guys, isn't that? Therefore, dy over dx is equal to, now we apply the power rule, a half times 1 is a half, x to the power minus a half. What's the derivative of a whole number, of a constant? 0. Now, write this with positive powers. This is equal to 1 over 2, x to the power 1 over 2. Don't get cornered by math. Math is like you are Ronaldo running with the, or you are Messi running with the ball, and you see Ronaldo coming and slide tackling you from the side. Let's go. That's the first one. That was type 1. Let's go type 2. We're following the same rules. Rules of differentiation, right? Type 2. What if I told you dx like this, and I told you root x minus 5 cube root x plus 4x squared all over x. Now we got to simplify, bring it to a straight line, then differentiate. Okay, in your answer, you leave it as dx. Don't put an equal to sign. You're still simplifying this. So root x is x to the power half minus 5 x to the power 1 over 3 plus 4x squared over one term over x. So that's over x, that's over x, that's over. Yes or no, guys? Let's simply, so who doesn't understand this? All we did, we took out the third signs and made it all over the same denominator. Dx, let's, algebra. Use algebra. Let's simplify. X to the power a half minus 1 minus a half minus 5x. A third minus 1 minus 2 over 3 plus 4. X squared divided by x1, x. Guys, double tick there. Up that stage, you understand what we've done. We've simplified the fraction. What's our next step, guys? Derivative, power rule. So this is equal to. Now you just say is equal to. The minute you say is equal to, you're applying now the power rule. So let's do it together. Negative times positive is a negative. A half times 1 is half x. Minus half minus 1 minus 3 over 2. We're done with that. Let's go to this. Negative times negative is a 5 times 2 is 10 over 3 x. Minus 2 over 3 minus 1 is minus 5 over 3. 1 times 4 is 4. X to the power 0 is 1. Now let's write this with positive powers. That's minus 1 over 2. X to the power 3 over 2 plus 10 over 3. X to the 5 over 3 plus 4. You'll get 5 marks for that. And one last one. Let's do one last one. And we're done. Let's see from this past paper. They're playing with us here. It's so easy. 4x to the power 8 plus square root of x cubed. Come on. They think we got time for. All right. One like this. Straight out of a past paper. One like this. It's quite similar. I'm sure you'll all be able to do it straight out from a past paper. I'm giving it to you now. Watch here. So they give it to you like this. They say d over dx, the fifth root of x squared plus x cubed. Come on. How easy isn't this? Question, answer. They just say determine. So comments coming in there? What? I'm not talking to them. What they saying? Right, let's go. So we got d over dx. We got x to the power 2 over 5 plus x to the power 3. Now this is equal to 2 over 5x. 2 over 5 minus 1, 3 over 5 plus 3x squared. This is equal to 2 over 5 x to the power 3 over 5 plus 3x squared. That's your final answer. Power rule. What they say?
They say you read the charts when they are talking to each other, but when they ask you not to read.
I finish the problem. Now and again, I check on the chats here next to me. My guy's not talking to me. What must I do? I'm not getting fed with the chats. Right, let's do one last one. last derivative dx. Let's see if you guys can do this one. Let's make one up, some interesting one. Let's say 4 times the cube root of x minus 2 times the square x all squared. Right, determine for 6 marks. Question, answer. Right. I'll give you 3 minutes to do it. I'll give you 3 minutes. I'm taking an oxygen break. Hey, we back. I hope you're done. All right, let's go. So we've got dx. That would be 4x to the power a third minus 2x to the power a half into 4x to the power a third minus 2x to the power half. I'm going to put a tick there. Did you all get that? Now let's remove the brackets. Let's FOIL it out. First, outer, inner, last. So 4 times 4 is what? 16x. A third plus a third. Minus. Right? 4 times 2 is 8x. A third plus a half is 5 over 6. Now my 2 inner terms is minus 8x to the power 5 over 6. My 2 last terms is plus 4x to the power a half plus a half is 1. Collect your like terms. 16x to the power 2 over 3 minus 8 is minus 16x to the power 5 over 6 plus 4x. Now that we just remove the brackets. Now we apply the power rule. We haven't derived yet. We haven't found the derivative yet. We haven't found the general gradient yet. We haven't applied the power rule yet. We do it now. This is equal to 2 times 16 is 32 over 3x. 2 over 3 minus 1 is minus a third. Minus 16 times 5 is 80 over 6, which is 40 over 3. X. 5 over 6 minus 1 is minus 1 over. Write this with positive powers over 3 thirds in the denominator minus 40 x to the 106 in the denominator plus 4. And that's your 6 marks. Differentiation is done. Principles, derivative, differentiation. What have we done so far in calculus? Pay attention. What have we done in calculus so far? We've done first principles. Right, so we all okay. We guaranteed. You're all okay. You're going to get your first 5 marks. Guaranteed, right? Derivative, you'll get one easy one. Derivative for 3 marks. So 5 and 3 is 8. You'll get a 5 mark or 6 mark question on differentiation. We've done it now. So 5 marks, 3 marks, 5 marks. 5, 10, we're already on 13 marks. Now we're going to do equations of tangents. Take this down because this is what you need to know. Then we're going to do the cubic graph. How many? So let's put our mark allocation here in red. This is the whole of calculus. 5 marks there, 3 marks there, 5 marks there. Equations of tangents, 5 to 6 marks there. Cubic, about 12 marks there. And last one, which we call optimization, which is calculus in real life. Application. Optimization or application is the same thing. 8 marks. 12 and 8 is 20. 26, 39. So I said plus minus 40 marks. There's your whole calculus on the side. So we've done first principles. We've done derivative. We've done differentiation. We're now on equations of tangents. How much time do we have before lunch? 15 minutes, boss. We'll continue after lunch with the cubic and optimization. Right, let's go. Equations of tangents. So, straight out of a past paper, give me a second. Right, straight out of a past paper. Straight out of a past paper. Right, the curve. Take this one down. We're busy with equations of tangents. All right, put the heading equations of tangents. Equations of tangents. Now, a tangent is a straight line, and it's always y equals mx plus c. So we always need the gradient and a point. This is very important work. We're almost into lunchtime. Right, so here we go. Exam type 1. Let's call it exam type 1. We're going to do about 3 or 4 examples, guys. Different styles. Right. Take this one down. The curve with the equation y equal x plus 12 over x passes through the point A2 and B. A2 and B. Find the equation of the line. Find the equation of the line perpendicular or 90 degrees to the tangent to the curve, to the tangent to the curve at A. 5 marks. Onliners, take this one down. How's our onliners doing? How are we doing, guys? How are we doing? How are we doing? So now the equation of a line passes through point. Right. So what you can do, let me show you a little art. Let's have some fun. Remember, we don't work through memos. We don't work with the memo. We take the question. We are the memo. Right. So now we got y equals z. So I'm going to say f of x is equal to x plus 12 over x. Step number 1. I'm just going to call it f of x. We got a point, A2 and B. Because we got an x value. Remember, I'm just going to take all this out. I don't need that. I'm just going to say I got the point A, 2, and B. So I got the x value. I need the y value. So I'm going to say step number 2, I'm going to say f of 2 to find the y value, to find the b value. Is going to be 2 plus 12 over 2. So f of 2 is equal to 12 plus 6. F of 2 is equal to 8. Yay! What do I have? I have my point, 2 and 8. So I got a point. I need, what do I need? Gradient. Once I got gradient and a point, guess what I got? The equation of a tangent. But they don't want the equation of the tangent. They want the equation of a line perpendicular to the tangent. Well, duh, we just play around with gradients. Right. So that was step number 1. I had to find x and y. Now I'm going to say f dash x. Wait, now I'm going to say f of x is equal to x plus 12 x to the minus 1, right? Now I'm going to say the general gradient. I need the general gradient is f dash x, derivative, is equal to 1 times 1 is 1, minus 12 x to the minus 2. That's the general gradient, my derivative at any point on this curve. Now we need to find the m of our tangent. Therefore, m of your tangent is going to be f dash. We got the x. How much is x? 2 is equal to 1 minus 12. X is 2 minus 2. Right. So I'm going to continue. Where must I continue? You're on the side. So, all right. Let's go back here. Therefore, f dash 2, we're now talking about the specific gradient. This is now the m of my tangent, is equal to 1 minus 12. 2 to the minus 2 is 1 over 2 to the 2. 1 minus 12 over 2 squared is 4, which is equal to 1 minus 3 is minus 2. Ha! Now we got a point A, 2, and 8, and we got the m of your tangent is equal to minus 2. There we go. F dash 2. F dash 2. Right? It's the same thing. It's minus 2. Therefore, the m of your perpendicular line will equal to, change the sign, flip the fraction. 2 over 1 will become 1 over 2. So now I got a point 2 and 8. And I got the m of my perpendicular line to the tangent. Now we find the equation of the perpendicular line. Therefore, the equation of perpendicular line, and you answer it exactly the way I've done it. Start here. This, all we did here was to find that. Then we simplified it. That was step 2. Then we found the gradient. Then that was the general gradient, the derivative. Then we found the m of the tangent, and that gave us this, minus 2. Then we found this. So this is step 1, step 2, step 3, step 4, step 5. Last step, step 6. Y minus y1 equal m into x minus x1. Y equals mx plus c. Let's do this. Y minus 8 equals 2. No, not 2. Half into x minus 2. We're using the new grade, the new perpendicular gradient, and we're using the point A, 2, and 8. So y minus 8 will equal to a half x minus 2 over 2 is 1. Here's your final answer. Moment of truth. Drum roll. Y equals a half x minus 1 plus 8 plus 7. There's your 5 to 6 marks for that. Boys and girls, give yourselves a nice round of applause. We start for second session. Master this. I'm going to write it here. Master. Learn. Right. We're going for lunch now until 20 to 2, quarter to 2 we start. We're continuing with more different styles. And then the cubic graph and optimization. Enjoy your lunch, guys. Enjoy your lunch.
They're not participating, they're just talking to each other.
Yeah, no. I know who the elements are. There's elements.
by your June exams. Have you registered university and which university you want to go to? I know you made mention of teaching, but are you sure about teaching?
Certainly, because the life steps katatam on tishala nai. So see, we are breaking the generational curses upper Guamcho.
Now, which university are you choosing?
I chose University of the Western Cape, CPUT.
Two of the universities that are they love protesting. Are you sure that you're not going to join the SRCs there and stop classes and examinations?
No. I ain't going to do any of that. No. Not me. Okay. That's not my style.
Okay, and just before I let you go, there are most probably people who will be watching this later or who are watching this live. What is your message to the class of 2026, the grade 12, who will be writing their exams now, and those who will be writing the end of the year exams?
Be smart. Don't start hard. Start smart. That's all the message I give to them.
Just before I let you go, be smart. Don't study hard. Study smart. How do you study smart?
Oh, but the use of past question papers, but the use of AI, Meta, that's the only solution.
Okay, I want to let you go. You've got any shout outs perhaps from your friends, your family, anyone who's watching at home?
Shout out. Okay. Yo, it's your boy Empty the Hustler. You're a rapper from Belazwe.
Thank you very much. And that is Anthem Joe coming from Sopumelela High School in Samora Machel, saying that don't study hard, study smart. And the best way to do it is to make sure that you learn through last papers. Now, I'm not going to make mention of the point which he made mention of that you've got to use AI, because AI can be misleading at times. But what we can do now is to try by all means to make sure that we go through past papers, which is what we are doing here. And if you perhaps need something to do, come down to Spine Road High School in Mitchell's Plain. We are doing the grade 12 pure maths paper, grade 12 papers. We are doing different topics. You can come here. Most of us do struggle with calculus at times, so this is the place to be. I'm Khalid Kungani Givaspadi. Thank you very much. I'll see you tomorrow.
Thank you, boys and girls. We are back. Thank you. Okay. Right. Take this one down. Find the equation of the tangent to f of x equal. Here's the easier one than we did before. Right, answer. That's an easy one. Thank you. Breaks over. Pass my Coke there, please. My Coke. Put this down. No, it's fine. I just need my Coke. Okay, here we go, guys. This is the easier one to the last one. So if you didn't understand the first one, which was a bit heavier than this, because the first one we had to find the perpendicular tangent. This is a straightforward tangent. Straightforward. Quiet. Quiet. Let's go. So all we're going to do now, we got the point. So now we say f dash x, general gradient, 6x minus 5. Therefore, f dash 2 is 6 into 2 minus 5. (12 minus 5 is 7. That's the m. That's the gradient of your tangent. Therefore, the equation of your tangent is the easy one. Guys, are you following? That's your general gradient, specific gradient equation. Now you'll find the learners who are saying, hey, quiet. You'll find that the learners who come to you and say, during the break, sir, we didn't understand, you want attention. Because if you paid attention, now you're going to get learners who are walking in, strolling in, making a noise at the back, and then they're going to come afterwards and say, sir, you went a bit too fast, I forgot to take it down. Don't waste your time, don't waste my time. So y minus 4. I can't go slower than I'm going already. This is like baby work. 7 times x is 7x minus 14. Minus 14 plus 4. That's your answer. And here we go. We are done. Was that difficult? No. Right, there's still learners coming in. Those learners who are walking in, please. This hall is built to echo, so even if you fart at the back, it sounds like an explosion in the front. Right. Right, I'm erasing. And I'm not keeping it on for learners who are just walking in now and expecting me to leave it on. You're wasting everybody else's time. Guys, these 2-day sessions are only those who want to get distinctions in math. Really. You focus on the on the OKAF and my program, I swear to God, you will get 100. You faff around, well, you'll do what they call in corporate, faffo. Faff around and find out. Many of you are willing to take that chance. You don't? You're willing to faffo. Don't faffo. Right. Let's go back to math. Right. Pay attention to one very important. The function, take this one down, f of x is equal to let's say x cubed plus ax squared plus bx minus 8 has a tangent given by g of x equals minus 4x plus 2 at the point B minus 1 and I don't know, make up a number. No, something that we don't have here. 10? 7. All right, done. You said 7, I say 7. It's not about the number. It's about how it's done. Right. Find the values of A and B. Or show that A equals something, B equals something else for 6 marks. Find A and B. 6 marks. Learn. So the first one, I asked you to find the tangent. Here, I'm giving you the tangent. We're working back to the equation. Remember, you got to know it upside down, inside out. You need to know forward and reverse. This is like driving a car. A car's got forward and reverse. You can't only be moving forward. You got to know how to reverse too. And the reverse is usually your higher order question. Forward is your easy, because you can see the road. Your reverse, you're looking at that and you're testing your judgment. And you're following a system to get back. So you got to know the forward to understand the reverse. That's math. That's math. It's life. Every quality in math applies to your life. Many of you ask, why math? Because math follows logical sequence. That's why companies, universities, those of you who get 100 in math, companies will take you first because you understand logic. Now take a person, please. Let me give you some marital advice and life advice. If you are mathematician and if you got logic, really, the first thing, don't ask what's their bank balance and don't look at how pretty they or how handsome they are. Look at their maths mark. Really, I'm not even lying. That's a life lesson, because a person, imagine you are a math specialist and a person did flippant maths light. You understanding calculus. That person is learning how to find train times and bus times. What the hell? How the hell are you going to have a marriage? Okay, you know what? Take my advice. You will, hello, hear me out. You'll remember me long before after I'm gone. And you'll say, yo, I remember one day the so tuned me. Check the maths result, Because you'll understand logic. Imagine you know logic and another person doesn't know logic. It's a disaster. It's a recipe for disaster. Answer. So if you ever take anything out of this entire weekend, let's say you even don't do well in maths, but you like, just think, hey, this uncle said, check the maths report, Life hack. Let's work backwards. When two graphs touch each other, Ish, Allah, you can get me a Red Bull. Bring. Right, here we go. When two graphs touch, what do we know? They are equal, am I right? But we also know not only are their functions equal, their gradients are also equal. So what you do, watch. Do it like this. I'm giving you a template. You learn these templates. F equals F, function equal function, gradient equal gradient. Right. So if function equal function, that means, let's do it together. X cubed plus ax squared plus bx minus 8 is equal to minus 4x plus 2. That's equation number 1. Equation number 2, simultaneous equations. Right, what's x? They gave you x, minus 1. Minus 1 cubed. Right, plus a into minus 1 squared plus b into minus 1 minus 8 equals minus 4 into minus 1 plus 2. So we got minus 1 plus a minus b minus 8 equals 4 plus 2. A minus b equals minus 1 minus 8 is what? Minus 9. 4 plus 2 is 6. 6 plus 9 is 15. That's equation number 1. Gradient equal gradient. So the gradient of f dash x must equal to the m of your other graph. So what's your derivative here? What's your power rule here? Come guys, watch here. So what do we have? 3x squared plus 2ax plus b. The 8 will fall away. Is equal to the m of your other graph. What's the m? Minus 4. And we got x. Guess what? We don't use a 7 at all. We're not even interested in a 7. 3 into minus 1 squared plus 2a into minus 1 plus b equal minus 4. 3 minus 2a plus b equal minus 4 minus 2a plus b minus 4 minus 3 minus 7. So b equals 2a minus 7 minus b equals 15 minus a, b equals a minus 15. So if b is equal to that and b is also equal to that, therefore 2a minus 7 equals a minus 15. I'm doing simultaneous equations. So 2a minus a equals minus 15 plus 7 minus 8. B equals a minus 15. B equals minus 8 minus 15. B equals minus 23. There's A, there's B. You'll get 6 marks for that. Now we're going to do another one where they talk about local maximum or local minimum. It's a, guys, these are templates. Guys who attended my workshops before, my premium learners that are on there, you can see I'm choosing different values just for you to practice on these templates so that you understand these concepts absolutely well. This is what I memorized in order to get 100 in matric. And now you play. Now you got a toolbox full of knowledge. I'll show you guys tomorrow how to complete the square in one line. When you're finding the equation of a circle whose center is not at the origin, I'll show you a hack where you can just look at it and get your answer. Tomorrow. Big day tomorrow. Analytics, circle analytics in the morning. After breakfast or after first break or whatever, trigs, 2D trigs. And then we end up with Euclidean and proportionality. Some crazy stuff coming tomorrow. Some things familiar, some things unfamiliar. Some things you've seen, some things you haven't. Right? Mathematics. Let's go. The last one under this before we go into the cubic graph. These are equations of tangents. All we're dealing now are right, now wait. The function f of x is equal to, let's see, x cubed plus ax squared plus bx minus 8 has a local maximum or minimum at the point B, 2 and 10. Find A and B. Find A and B. Find A and B for 6 marks. Shh. Can you see the variety? Can you see the nuances? Can you see the change in style of question? The first one was direct. Find the equation of a tangent. The second one, 2 equations were given. Work backwards to find A and B. This one talks about local maximum, local minimum. I want you to learn a rule and remember a rule. Anywhere in mathematics where they talk about maximum or minimum, derivative must equal to 0. Write that rule down. Whenever they talk about minimum or maximum, that is your clue. Make derivative equal to 0. I hope, my wish is that many of you who didn't understand calculus this morning are having a better understanding of calculus now. If you are shaky with calculus, this will make you solid. This is mind gym. Right, answer. Now all you do, you need a function equation and you need a gradient equation, equation 1 and 2, because we're solving for A and B, so guess what? Hey, all right, anyway. I'd rather go because a lot of you were battling with this. Right, pay attention. Function equation, plug and play. Put it in here, x and y. So what's y? 10 equals 2 cubed plus a into 2 squared plus b into 2 minus 8. That's your function equation. You plug and play, substitute x and y. 10 equals 8 plus 4a plus 2b minus 8. 4a plus 2b equals 8 minus 8 will cancel. We're left with 10. Divide everything by 2 to simplify. 2a plus b is equal to 10. Equation number 1. Gradient equation, derivative. Derivative. So 3x squared plus 2ax plus b, right? The derivative of that must equal to 0 for minimum or maximum. And I promise you, my friends, yeah, damn, ice cold. Here we go. Oh, where? My O. Right, let's go. Guys, these are templates. Flip and learn. I beg you. I'm just being a bit kind. I'm using better adjectives. Right, 3 into, what's your x? 2. Plus 2a into 2 plus b equals 0. 4 times 3 is 12 plus 4a plus b equals 0. 4a plus b equal minus 12. Quiet. B equals 10 minus 2a. B equals minus 12 minus 4a. Equate the two. Yeah, what happened? What? Did I make a mistake? Where?
Anyone wants to note the mistake?
4, 8 so 8 minus 8 is 0. 4a plus 2b equals 10. Divide by 2. Divide by 2. 2a plus... Oh! Okay, no, don't worry. Don't worry. Found it. Come back. Thank you. 2 divide by 2 is equal to 5. So b is equal to 5 minus 2a. B is equal to 12 minus 4a. 5 minus 2a equals minus 12 minus 4a. Minus 2a plus 4a is equal to minus 12 minus 5. Am I right? 2a equals minus 17. A equals minus 17 over 2. B equals 5 minus 2 into minus 17 over 2. 2 and 2 will cancel. B is equal to 5 plus 17. B is equal to 22. Thank you for that. When I heard raucous at the back, then I made a mistake here. Now we're going into the equations of tangents and optimization. What's our time like? Damn, it's 20 past 2 already. 3 o'clock on the dot, we are here. Gonna go till 4. Too much for you. Too much maths for one day. Never, come on. Next weekend, I have a workshop from 7 p.m. to 3 a.m., then from 8 a.m. until 4 p.m., and then the Saturday night from 7 p.m. to 3 a.m., and then again from 8 a.m. until 4. Around the clock the entire weekend, only doing freaking math. It's normal. It's normal. We eat, sleep, and shit logs. No pun intended. Right, let's go. Right. The cubic graph. Put the heading, the cubic graph, the cubic function. So now we tell you f of x is equal to x cubed plus x squared minus 5x plus 3. Sketch. How many of you here have never done the cubic graph before at school? 6 of you from 10,000. Masha, well done. Tell yourself I said congratulations. Best in South Africa. Right. Right, what do we need? We need the y-intercept. We need x-intercepts. We need turning points. And another word for turning point is stationary points. And we need what we call the point of inflection. Second derivative. So let's get the y. So in your answer, that's your checklist. That's what we need. Right, here we go. How do you get your y-intercept? Let x equal to 0. Yes or no? Right. Now we use the factor and remainder theorem. That's step number 1. Step number 2. We try f of 1. right? You try 1, 2, minus 1, minus 2. We must get 0 as a remainder. For a number to be a factor, so we must have 0 as a remainder. So let's try this. For every x, I'm going to put 1. 1 cubed plus 1 squared minus 5 into 1 plus 3. 1 plus 1 is 2 plus 3 is 5 minus 5. Therefore, x minus 1 is your first factor. Why x minus 1? X minus 1 will equal to 0, x will equal to 1. Now I'm going to put this one in blue. So you know that this number here, now I need my other two factors. Remember, it's cube. So I need either 3 factors, 2 factors, or 1. I could have 1, 2, or 3 factors. But a maximum of 3. So now we use step number 3. We use what we call synthetic division. Now let me explain to you what synthetic is. You take this 1, you put it outside. And then you put all your coefficients inside. 1, 1, minus 5, 3. Pay attention. Pay attention. Shh. We got one factor. We're short of other factors. So pick up this 1 here from inside. Again, long division. So you multiply and then you add to the next term. So when you come across, you multiply and then you add to the next term. So 1 times 1 is 1. 1 plus 1 is how much? 2. Repeat it. 2 times 1 is 2. 2 minus 5 is minus 3. Minus 3 times 1 is minus 3. Minus 3 plus 3 is 0. There's your answer on the top. Your quotient is your answer, 1x squared plus 2x minus 3. We factorize that. We're going to get x, 3, 1, plus, minus, and then your first factor that you found as well, x minus 1. There we go. Equals 0. X is equal to 1 or x is equal to negative 3. There we go. We now found our x-intercept. So you do factor and remainder theorem to get 0. Then you do synthetic division. Why are we doing? To get that. That is that. And then we factorize it here. Agreed? So I got my intercept, I got my x-intercepts. What am I short of? Turning points, and that's always derivative equals 0. Why? Turning point is your maximum and minimum of your graph. Derivative equals 0. So let's go. Right, so we got all of this. So what do we have? We got y is equal to 3. Let's write it here on the side. Y is equal to 3. X is equal to 1 or x is equal to minus 3. Right, we now need our turning points. So derivative equal to 0. Now guys, if you got your factorizing calculator, you don't need to do the synthetic division. Just put it into your calculator, mode, equation, cubic, in your values, and it will give you your x values. Not a problem, you'll get full marks. No, that blue calculator won't do it. No, no, that's the one you play soccer with after school. Just kick it over the fence. Yeah, right, turning points. So f dash x is equal to 3x squared plus 2x minus 5. Power rule is equal to 0. Break that up, equal to 0. 3x and x, 5 and 1, plus, what's your 2x values? X equal minus 5 over 3, or x equal 1. Now you take x values, you put it back into the original. F of minus 5 over 3, get my y value. You get 9,48. And now you do f of 1, and you know you're going to get 0. So now your two turning points is minus 5 over 3, 9,48, and then the other one is 1 and 0. To get your point of inflection, double derivative, second derivative, f double dash x is equal to 6x, sorry, I'm dying here, 6x plus 2. 6, 6, yo. Wallah, you people laugh. Even if I must die here, everybody will clap. Minus 2 over 6 is minus 1 over 3. Plug it in back into your original. You're going to get 4,74. And there we go, we are done. Turning points, point of inflection. There we go, we got everything. This is the only time you use second derivative for the point of inflection. Now I'll show you what it is. Those of you who have never done it before, just take all this down. After we plot the graph, I'll explain to you what it means. Right. Let's sketch the graph and analyze it after sketching it. So what did we have? Our two turning points was what? Minus 5 over 3 and 9,48. The other one was at 1 and 0. My point of inflection was minus 1 over 3 and 4,74. So those two go together. That's on its own. That's on its own. That's on its own. Right, let's go. Let's draw the graph. Let's sketch the graph. Here we go. Right, that's 0. Y is equal to 3. 1, 2, 3. X is 1, or x is equal to minus 3. That's 1 and 0. Minus 1, minus 2, 3 and 0. My two turning points, minus 5 over 3 is minus 1,67 and 9,48. So I'm saying minus 5 over 3 would be there, and 9,48 there. Minus 5 over 3, 9,48. Put a dotted line through the x value of your turning point. Here's another dotted line through that x value of your turning point, 1 and 0. Right. That we'll put in last. Right. Now, it's a positive graph. Remember, it was x cubed, so it's positive. So it's from the bottom up. So we go increasing, 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 stationary. Decreasing, decreasing, cut. Decreasing, decreasing. It's supposed to cut here, but this is also your turning point. It's also your turning point, so it bounces here. And that is graph F. And where is your point of inflection? Minus a third and 4,74. There we go. That green dot there is your point of inflection, minus a third and 4,74. And there we go. Our graph is fully sketched. Now they're going to ask you for which value or values of x is the graph increasing. You know which value or values of x is f of x. Let's make it interesting. F of x greater than 0. Greater than or equal to 0. For where is f of x less than 0? For which value or values of x is f of x increasing? Where is f of x decreasing? Where is the graph concave up? And where is the graph concave down? You know you got to learn this. Let's answer it together. Greater than 0 means positive above your x-axis. So it says for all your x values greater than minus 3. Going right through to infinity. So for x greater than or equal to minus 3. Where is it less than 0? There. For all your x values less than minus 3. Where is the graph increasing? So it means it's going in that direction. It's increasing there and it's increasing there. Quiet. So where is it increasing? For all your x values less than minus 5 over 3. Or for all your x values greater than 1. Remember, a line going this way, that's increasing, increasing, increasing. That's increasing, increasing up to your turning point, up to the x value of your turning point. Decreasing, it turns here and comes down there. So here's decreasing. Let's do it in a different color. That's decreasing, 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 decreasing. So it's for x less than 1 but greater than minus 5 over 3. Concave up, concave down. You look at the x value of your point of inflection. So concave up is a smiling face. So from your x value here we go. Here's your smiling face. So for all your x values greater than minus a third. Concave down is your sad face. X value less than minus 1 over 3. This is your point of acceleration. Basically, this is your point of acceleration. Increasing, decreasing is your speed of the graph. Are we all okay? I hope you're taking this down. Learn it. Now, Watch the next one. How's our onliners doing? Guys, are you following? Onliners, are we good? Yeah. Some of them, they're wasting their time. Right. Now let's do the reverse of this. It's 14:35. We only got 25 minutes left. Can you believe it? Right. Let's do the reverse. Where? Sir, for point of inflection, can you not use F double? Yes, we did. Mango fish, point of inflection, we did use F double dash X equal to 0. Here we go. Right, now have a look at this. What if they gave you a graph? What if they gave you a graph and they gave you the two turning points of the graph? Let's say they told you that this point here is 2, the turning point here is 4 and 10. The other turning point here is, I don't know what, 8 and minus 6. Right, they tell you that this is graph F and F of X is equal to, let's say, X cubed plus AX squared plus BX plus Q. Find A, B, Q. So find the equation. Find the equation of F. Right, pay attention. It's worth 6 marks. Right, answer. I'm giving you a template. Whenever your so we know our Q value is 2. Our Q value is 2. The first thing I want you guys to do, cancel the two Y values. You're not interested in that. I'll show you what to do. So you can call this SP1 or turning point 1, SP2. Because we're dealing with minimum or maximum derivative. So this is where you start. F dash X is equal to, find the derivative of that, is 3x squared plus 2ax plus b. The x is 1 and the q will fall away. Now you do SP1 with 4. So this is equal to 3 into 4 squared plus 2a into 4 plus b for minimum or maximum. Remember, that is maximum. This is minimum. What did I say? For minimum or maximum, derivative is equal to? There we go. Is equal to 0. So 16 times 3 is 48 plus 8a plus b equals 0. 8a plus b equals minus 48, equation number 1. Now we do SP2. Let's take the 8 and put it into there. So 3 into 8 squared plus 2a into 8 plus b equals 0. 8 squared is 64. 64 times 3 is what? 192? I don't know. What's 64 times 3? Check. $192. Always right, never wrong. I'm lying. Right, there we go. Now just solve for A and B simultaneously. There we go. Right? Let's give you another one. One last one to find the equation of. And then I'm going to give you the, I'm going to sketch the derivative. The derivative is a parabola. The derivative of a cube is a parabola, 1 power less. So 1 power less than a cube is a square. Right, last one. Let's give you one that goes like this, bounces here. Let's say I give you a point on this graph and I tell you that is 0 and 2. Let's give you that point there and that point is 4. Now let's make that 3. And let's make this -1. And let's call this graph G. And I tell you G of x is equal to ax cubed plus bx squared plus cx plus d. Find A, B, C, D for 6 marks. Basically, find the equation of G. We're almost done. We're almost there. It's 20 to 2. We got the last 20 minutes. Yeah. Yeah, no problem, Mango Fish. I don't even know what you're asking. Right, here we go. Pay attention in our answer. Right, now we go y equal a into x minus x1 into x minus x2. But because it bounces here, we square it. Because it bounces, because the graph bounces there, we square it. So we're solving for A. This is 0 and 2. So let's go. 2 equals A into 0 minus minus 1 plus 1 into 0 minus 3 squared. Quiet. So 2 equals A into 0 plus 1 is 1. 0 minus 3 minus 3 squared. 2 equals A into 9. A equals 2 over 9. So G of x equal 2 over 9. That's your A value. You're looking for A into x plus 1 into x minus 3 squared. Now they want it in this form here. So all you have to do now is remove the brackets. 2 over 9, x plus 1, and now expand that, x squared minus 6x plus 9. Now multiply it all out. So G of x equals 2 over 9, x cubed minus 6x squared plus 9x. Multiply that out, plus x squared minus 6x plus 9. G of x is equal to 2 over 9 into x cubed minus 6 plus 1 minus 5x squared. 9 minus 6 is 3x plus 9. Now multiply this inside. So your final answer, G of x is equal to 2 over 9x cubed minus 2 times 5 is 10 over 9x squared plus 6 over 9, or 3 goes into 9. 2 over 9 times 3 is 2 over 3 plus 2 over 3x plus 9 and 9 will cancel, 2. We don't think we're right. We know we are right. because it cuts at 2. How do you get the y-intercept? Let x equal 0. So you get 2 here and it's 2 on your graph. You don't think you're right. You know you're right. Why ne? Okay, now we sketch the derivative from a past paper. Watch this, very important concept. If finish this up for today, it's 2:45, we got the last 15 minutes. Then I will do optimization first thing in the morning. Let's start at 8:30, start 8:30 sharp tomorrow morning. I spent a lot of time on calculus because I know many of you from the beginning, you already told me, please spend time on calculus. Right, watch here. From a past paper, take this one down. They give you that. They give you that. They tell you this is f dash x. This is calculus, eh? Not functions. They call this point A, they call that point B, they call that point C. B's coordinates, 3 and 0. C's coordinates, -1 and 0. A's coordinates, x and y. That's your y-axis. Given in your exam, they say sketched is the derivative of f. Right, question number 1. They want the coordinates of turning points of f. Number 2, they want the x coordinate of the point of inflection of f, for which value or values of x is f of x increasing, decreasing, concave up, concave down. And the last question, find the derivative of f. Now this is not graph f, this is f dash. How many marks? This is a typical exam question. This is exam. Master this. Right, pay attention. Now, it's very nice. Listen, guys, great. We're almost done. Pay attention. The x-intercepts of your derivative, the x-intercepts of your derivative are the turning points of your original. Write that rule down. Your x-intercepts of your derivative are your turning points of your original. So the coordinates of the, I just want the x, okay, so the coordinates of the x coordinates of the turning point, so x is equal to 3 or x is equal to -1. Just to show you, pay attention. It's a positive parabola. That means it had to be a positive cubic graph, the original. This is f now. This point here and that point there, my two x values. This x value here is 3. And this x value is how much? -1. Right. The x coordinates of the point of inflection. Pay attention. It's your turning point of your derivative. This is your point of inflection. Your turning point of your first derivative. It's a point of your turning point. The second derivative. The derivative of the derivative. Your turning point of your first derivative. The turning point of your first derivative is your point of inflection. So how do we find this value? From your knowledge of functions, it's the midpoint. Yes or no? So if it's 1 unit here and 3 units here, there's 4 units here between the two. We want this value here. So 1 unit here, 1 plus 3 equals 4. And the halfway mark, we divide it by 2, we get 2. So 2 units this way or 2 units that way. What is this value here? 3 minus 2 is how much? 2. So x equal 2. Your midpoint, 1. 3 minus 2 is 1. I was checking if you were paying attention. X is equal to 1. Well done, you paying attention. Right. For which value or values of x is f increasing? Increasing is there. So for x less than 1 or increasing there, x greater than 3. Decreasing, yeah, for x less than 3 but greater than -1. Concave up, you grab here, here's it from here, smiling face. Concave up is from 1, x greater than 1. Concave down is this side here. For x less than 1, the x value of your point of inflection. We're almost done. We have got like 3 minutes left. We at the end. We're going to open up with optimization tomorrow morning. Then we'll go into circle analytics. I'm going to combine circle analytics and normal analytics together. Last one. Find the derivative. That means they want the equation of the parabola. And that we know. All we're going to do there is what functions, what we know from functions. How do you find? So we're going to say f(x) is equal to x minus x1 into x minus x2. F dash x, which is my parabola, is x plus 1 into x minus 3. So f dash x is equal to x squared plus 1 minus 3 minus 2x minus 3. There we go. That is your derivative. Boys and girls, we've come to the end today. I'll see you guys tomorrow, 8:30 on the dot. No long stories tomorrow morning, brah. We're kicking off 8:30 tomorrow morning. Optimization, analytics, circle analytics, Triggs and Euclidean. Enjoy your day, enjoy your day, enjoy your day. Thank you all for coming. See you guys tomorrow.